Hello, hello, by the way. We're just starting a new stream. Alright, latency should be better. Alright, here we go. Should be a little bit better. Better. Nice. I also changed a couple of settings on the stream itself. So we should be good. Alright, so MCTP is like the default way to make a message, and I guess SPDM is an extension of that, which is a bit more secure. Alright. Less than 4 seconds. Alright. I like the fact that I used image to PDF, like the Linux utility, and it scanned part of the image as text. Because of course, not having a Chinese account, not having a Chinese identity, makes it impossible to download shit. The Chinese on a hinge. Alright. It is possible to use CMA SPDM in many scenarios. For example, remote system administrators can dynamically generate manifest of cryptographic identities of components of a system, especially at the level of the removable unit, add-in card module, without physical examination of the system, via BMC or other platform root of trust. The identity of a function can be verified by OS drivers before assigning resources to the function during runtime unplug scenarios without requiring an host reboot. Alright, virtual machine monitors or the security manager. I think they're using these two terms because like one term is this is AMD and this is Intel. Can establish the hardware and firmware identities of a function before assigning it to a virtual machine, and provide a service such to enable these to be confirmed by the virtual machine guest directly with the assigned function. Alright. So so from reading this, what I understand is that you don't have to, like you can do checkups of a thing plugged in PCIe without like inherently trusting the host. You can verify that whatever the function you're trying to do, whatever the, like let's say you're sending to an accelerator, it will truly be the accelerator, it will truly be the thing that you're trying to do. And this would be making sure that you're not like sending things not to the right place, I guess. Or this is a reiteration of whatever the fuck I said earlier. Okay, the high-level overview of the CMA SPDM security feature and their associated PCIe-specific requirement are given in the following section, whereas the foundation architecture protocol and message definition for the security exchange used by CMA SPDM are defined in SPDM. Okay, so how the communication is going to be done is defined by SPDM. Okay. So no big change, I guess. The message exchange between the requester and responder for CMA SPDM security features are denoted as CMA SPDM message. Okay, so when we talk about the new version of SPDM, we say CMA SPDM. All right, makes sense. Implementation note, understanding and implementing CMA SPDM. CMA SPDM is part of a layered architecture to support device and platform security. I guess it's, okay, see this, oh, it's not this figure, it's this one. Okay. Building on the DMTF security protocol and data model specification, goddamn, DTMF SPDM, CMA SPDM provide a mapping of that foundation, with the intent that future SPDM enhancement can, in most cases, be implemented without requiring modification to CMA SPDM, in addition to device authentication and firmware measurement capabilities such as mutual authentication and cryptographic key exchange are also possible. Following SPDM, CMA SPDM uses the term requester to refer to agent initiating the CMA SPDM protocol request and responder to refer to an agent that ultimately serves those requests and generate responses. Depending on the use model supported, it may be desirable to implement support for more than one way of transporting CMA SPDM request and response. All right. So root complex, that would mean CPU side. System management controller. Okay. Okay. Alright, so this is kind of saying that you can pass through a switch to do your shit. And you can be like both sides of the transaction, I guess. Oh, there's an explanation. 6-48, which is this. No. Fuck. It's this one. Shows an example of a device that supports multiple platform use model and multiple access mechanism. In this example, there is a system management controller, SMC, that has an out-of-band connection to the other element in the platform, enabling it to use CMA SPDM even when the PCI links are not active and or fundamental reset is active. Okay. Okay, so that's what this shit means. Okay, so when they say PCIe link, they mean like a full PCIe, like secured, up-to-date thing. And when they say this, they mean pretty much any other fucking way to get information to a thing. So you don't necessarily need PCIe to make shit work. You can also go through other means, but still implement this thing. CMA SPDM can be used via SPDM MCTP. The root complex can use CMA SPDM over DOE. DOE is data object something. It's the other thing that comes in this release of PCIe. In this platform implementation choice, it is a platform implementation choice of which method are used. Okay. DTMF is open. Yeah, but DTMF is old as fuck, man. Oh, no. I guess it's something that is always being worked on? Doesn't look that old. Alright. Okay, we were in that document earlier. Oh, okay, I get it. Okay, so it... Oh, okay. So... Okay, DTMF is like the group, right? It's the copyright, we could say. Right, it's the groupings of people coming together to do something, and SPDM is the type of technology they're doing. So when we say DTMF, fuck, DMTF, I always mix them. Okay, DMTF, SPDM, we are saying the SPDM created by DMTF, which is the only one that exists. Okay. Right. Okay. Alright. Just make sure that I clicked on the right thing. So that's probably like how we send information. And that's about it. Like this... I just like scroll the fuck out. But I think that this is more... This is not an hardware thing. This is a how you tune your software. I just want to say if they're talking about like timing and shit in there. Because if so, that would tell us that they're also talking about hardware. But it doesn't seem so. Like, I know that the hardware needs to be, like, made for it, of course, but, like... Yeah, that would be sick! God damn, I don't have the brain for this shit. Fuck. Okay. Just already we've... Like, we already have... Am I on the right track? Anyway. Like, we already have a better knowledge. Thank you, MB. So, SPDM... That's like the way of sending a message. How you arrange the bits, right? And... I guess... that what we're reading here is more or less the hardware side of things. So what we're... Okay, so you're saying yes to the SPDM part. So what we're reading here is more in relation to the hardware. So it's saying if you want to do CMA SPDM, you can do it through the means of PCIe. You can do it through other means using this specification, MCTP, right? To SM bus. All right. Okay. Yeah, it would be so cool if we could like show like per bits. That would be on Hinge. Okay, we need to put the music again. I really need to just download it and like put it on loop. Okay, that's what I'll do. Oh, I'm so lazy. Okay, stop downloading and get to playing. I want my music. I don't want to open it with Handbrake, you bitch. Oh, whoops. Okay. Alright. What's the name of the music? It starts by W. W Mozart. Can I like loop that shit in MPV? Alright, that's a start. Where's the loop? Okay, it may start playing random shit that I don't want it to, but we'll live with it. We'll live with it. Alright, where were we? Okay. So here we have the controller, so that would be like TDX or AMD TIO. No, I'm a dumb fuck. This is a module. This is the GPU or something else. So it has a function, represents a function itself. Okay, so it can do a thing. Represent themselves as a... Okay, so you can like divide it, I guess. Like this makes a lot of sense when you add it to what's written in the TDX part. Like, let me just show you an image and it will like, a lot of things will click. Like this image. Okay, this image says it all. So, like the idea, at least I've only read TDX Connect, right? But the idea here is that the CPU is the one taking care of this whole bullshit. So it has control over way more than we think about. So first of all, we have a memory controller that encrypts the RAM for like VM specifics. So it already has the keys to decrypt this shit and work with the VM to send the data. So how about we like allow this link to also exist towards a device, right? So you pass by PCIe, you go to the device. So let's say that this is an accelerator. If the accelerator has the ability to manage multiple VMs at a time, well, you can just say this, like, this accelerator could have the capability to store multiple VM information inside of it, still be isolated, or if it doesn't, it could have the ability to be completely locked to one thing, right? So here we have another example where it goes through a bridge. This is to demonstrate that the bridge isn't secure and we don't trust it at all, but because the communication is encrypted, this is what IDE stream means here. So because the communication is encrypted, we don't really give a shit. And here, the VM, well, this one, has complete control over device 3 and can do whatever the fuck it wants with it, without the host having any say on it, because it is a device compatible with this thing, TDX Connect. Well, it would be a PCIe IDE. And I don't know if I said it, but it makes even more sense. Like, here it's written PCIe root complex with IOMMU. That's not for nothing, it's because they want to make sure that it's obvious that the device 1, if given the right, is able to go read the memory of VM1 or certain part of memory. So like that start making a lot of sense, right? Oh shit, I don't know if I explained it yesterday. But okay, so normally, if I'm yapping, it's okay. It's good for my, if you think I'm wrong somewhere, tell it to me, okay? But I'm just trying to build my understanding. Technically, the way that it works, I have it even written, I think. +1 for the graph. Yes, we need to include this. This is not like, this is not copyrighted Giga, Giga get banned of the face of the earth if publish information, so we're gonna be good. But I think I wrote how it works before. I'm just going to read this. I rewrote this yesterday. The best way to see if we understand is to explain it. Yes. Now let's take a moment for us to understand how communication between PCIe device and secure VM normally happens. In a secured VM, the memory of the VM is encrypted. This removes our ability to ask the PCI device to read the VM's memory directly through DMA. This forces us to use software I/O virtualization of the PCIe device. The host will supply the VM with a shared buffer that will then be used by the PCIe device. This is slow and untrusted, and in the event that the PCI device, say the GPU or an accelerator, doesn't have encryption or decryption capabilities, it would also force us to leak secrets. So that's my explanation for how things work. I think I explain all there is to it, right? Because the idea is we cannot have hardware things because PCIe is not secure, so there's no way for us to have that communication. Explain how this force leaks secret. I think the image would bridge that gap, right? Because I don't know how I can say in more obvious terms that the TDX instance has to put things into a VM that is controlled by the host, into a buffer that is controlled by the host, not the VM, and then pass over the thing to the device. That's the issue here, right? So if the device doesn't have encryption, then by default the shared buffer is leaking our secrets in plain text. So that's not an issue for a network card, right? Because a network card, like, everything's encrypted. At best, they know where you're sending shit, which they would always know, right? But for a GPU doing processing, an accelerator, this looks like shit, right? Which secrets? Oh, okay, you mean... Okay, so... Okay, I could explain that better, you're right. So, where do I say? This could force us to leak... the information that we send to the buffer, the information we want to process. Does that make it clearer? I'll read it from here. This forces us to use a software I/O virtualization of the PCIe device. Maybe this part of phrasing is not the best. This forces us to use a software I/O virtualization of the PCIe device. The host will supply the VM with a shared buffer that will then be used with the PCIe device. This is slow, untrusted. In the event that the PCIe device, say a GPU or an accelerator, doesn't have encryption-decryption capabilities, it would also force us to leak the information that we send to the buffer, the information that we want to process. That pops in mind. I might also know the answer. No, it's really good because, like, okay, this is how I view my my channel, okay? The reason why people like videos like the kernel videos is because they feel like they have an understanding for something. They really probably don't, right? Because they vibe through the explanation. But when we give these little detail, it prevents a lot of checking out because somebody focuses on something that is not answered. Yes, secrets is a bad word, you're right. Because it's proprietary. Yeah, DMA2 would need to be replaced in that view, right? Directly through a DMA. And here I could do like a 2-second experimentation. Which is when the PCIe device would read a section of memory without the CPU's assistance. DMA is more common. It exists since forever. I agree. But if you would have asked me like 6 months ago what DMA is, I couldn't have answered you like solidly. So, and I had made multiple kernel videos at that time, right? So what that means to me is that most likely 90% of the people looking at my video have no feeling for what DMA is if I just throw DMA. But if I give more context to it, it is more understandable, right? So let's just read this and see if it vibes. Because there's a vibe aspect to it, right? Let's just start from here. In a secured VM, the memory of the VM is encrypted. This removes our ability to ask the PCIe device to read the VM's memory directly through DMA. Oh well, fuck, I already explained it here. Yeah, it would be a repetition. Less understood than I thought. Yes, because there's people like Nigma, okay? There's people like Nigma that goes and say that DMA is not when a PCIe device reads memory. Anyway, he's triggering me sometimes. Holy shit. Technically, and then understanding goes out the window. Okay. Okay, enough derailing. In the event that... Okay, now I think that this block is pretty good. Okay, this block is pretty good. Where the fuck were we? Let me just reframe all of this. Okay. Okay. Yes. So I was trying to like make a complete understanding. So right now, whenever we want to do this, whenever we want to transfer to a PCIe device, we go from... I would like to be able to make that trust compute boundary like a thing that you could feel. This may sound unhinged, but... Oh, I think I go more into it here. Maybe. Because I feel like thinking of a castle, thinking of a wall, is like a really good analogy for this. Oh yeah, this is where I go. Let's just read this Intel TDX Connect that I did half sleepingly yesterday, while trying to strip a fucking Chinese website. Intel TDX Connect. Intel TDX will use what we call, not what I call, bitch. Okay, what we call the trusted execution environment to ensure that confidentiality is kept. It is essentially a secured CPU mode that will perform the management of the VM on the behalf of the host. The trust compute boundary, which is the limit of the secured environment offered by TDX, is normally limited to CPU plus memory. Intel TDX Connect extended by using, and then this is why I had to go into the extended PCIe standard to try to know what the fuck IDE meant, because it doesn't mean IDE like old hard drive. Old hard drive? Question mark, question mark? All right. I think IDE is just their name for the PCIe standard. Where is IDE in this? IDE. Integrity and data encryption. Extended PCIe capability of integrity and data encryption for confidentiality. Goddamn. All right. I don't know, maybe it will get into it. And I'm a little bit of a dum-dum. It would be so cool. You're so right that it would be cool to be able to make like a bit perfect message. Oh, secured CMA. Okay, that's the thing, right? That's the thing. That's where we're going to understand this. Okay. Let's resume our understanding of the underlying or it's more like a mount. We're doing the Mountain Bailey. Is that the thing? Mount and Bailey? Mountain Bailey? Anyway. But yes, it is I don't know, like moat, mount and Billy. Anyway, I don't know if these words are like too big, like too like out of context. I have no idea what the fuck you're talking about, but but the image is good. God, I'm coughing my way up. Oh. Oh, really? So it's okay. Wait. I know the name. Nduve. All right. Okay. Yeah, we may we're getting too deep in D&D. That may be the issue, but I think that just the like I could make an animation, right? What I could do is do like shit. Like bro. Like I could do this. And I could say, okay, so this is for the CPU and memory. And I could make the little animation thing do whoop and do like PCIe da your GPU. So like this could be visually appealing. And me just saying like, oh, there's a wall, right? There, we have a wall, we are protected, we are inside of the castle of the CPU and memory, and what we're doing is we're extending the walls to get to PCIe GPU. I think it will... at Maple Circuits, the anime. Oh no! No, we're not doing anime. The Maple Circuit anime. Yeah, the animation, like the idea of the animation needs to be there. It needs to. Let's just end our the animation you just described. Yes, that it needs to be like visually. It's simple and it gets the point across. Anime. Yes, Rust. We're reading some boring ass. Is it PCIe 7 specification, okay? We're just here for understanding. But, oh man, MB, you put this in my mind and I love it so much. If we had like the whole process mapped out, bit perfect. Holy shit, that would be so cool. Okay, we need to resume reading. Okay, so our understanding... CMA SPDM. It is the process by which PCIe links communicate. It doesn't have to be encrypted, but it will get to the right destination, and it can be done through something else than a PCIe link. So you can offer the same communication by other means. This is the TLDR of what we have. Correspondingly, a device controller can support CMA SPDM in multiple ways, depending on the associated form factor and platform requirements and implementation choices. For maximum flexibility, it may be desirable to support all of the following. Out of bound. Out of band. Oh, that's what they fucking mean. Alright. Alright, I'm getting there. Over SM... When they say SMB, am I like system management bus? Okay, so we're talking about basic ass thing. Okay. Alright. Okay, I think I understand a bit more now. Like I2C, I3C, I know them, but... Using MCTP. Okay, so MCTP would be I think the standard for communication that DTMF outlines, not for PCIe communication, but for outside PCIe communication. Right, that's what we were... No, that's the SPDM. Yeah. So, okay. Alright. Okay, so kind of says you need to have this signature. Okay, okay. I think whoops. I think I got it. According to the specification... Alright, so follow the specification. You can send it over here. In-band using MCTP encapsulated in PCIe messages. Okay. So you could send the same message as out of band, but from PCIe if you encapsulate it. Okay. In band using the configuration mailbox mechanism defined by DOE extended capability. Okay, that's the... Okay, yeah, that's the thing for the VM. According to the specification for SPDMs, CMA and DOE. We need to read DOE. Shit. Womp womp. Try to do a fast one. But we'll have to read DOE as well. God damn. I think this will give us a better understanding of the, like, bit perfect message. Data Object Exchange is... Data Object Exchange, DOE, is an optional mechanism for system firmware/software to perform data object exchanges with a function or RCRB. RCRB? Fuck, that's not what I wanted. RCRB? Where are you, RCRB? Okay. Okay, root complex register block. Not sure it makes more sense. Bro, there's not that many pages in this document. Am I missing some pages? God damn. I'm missing pages, guys. RIP. Alright. It was like 937 or something? Or 69. It was 69, look at this. Okay, we're near it, I guess. DOE, where are you? I'm trying to understand here. Okay. I should have copied the definition for this shit. God. That's a dumb thing. Root complex. Okay, so root complex register something. Like gives you information on what? On the would that be like the bridge? Like the motherboard? That gives us that information? God damn, I'm confused. I feel like there's a lot of things that, well, we're so deep in it that, like, they assume that we're giga big brain. One day I'll have YouTube videos on every fucking one of these acronyms. I'll get all of them. I'll get all of them. Okay, let's go back to the start. So DOE is an optional mechanism for system firmware slash software to perform data object exchange with a function. So when they say function, what they mean is like a GPU, an accelerator, like a target thing, or RCRB. Okay, so they mean that you can do that communication with these registers. Okay. Yeah, my friend, this doc is only for the based people. Not available if you're not part of the cool club. Software discovers DOE support via the Data Object Exchange Extended Capability structure. Yes. Yes, because it needs to, like, set a bit. There's a way that PCIe detects and detects capabilities, and it's part of these extended capabilities. Because of the DOE depends on the... You meant the previous one. What, this one? You're gonna need to explain. Is it the Obsidian? Is it on Chromium? Is it AI? Is it... Oh, it's docs.rust. Okay, okay. Okay. Okay, got you, bitch. Got you. I got it. I got it. Thank you. Because the DOE depends on configuration request, it is not usable for peer-to-peer operation directly between functions. Lol. Okay. Although the system software can provide a mechanism to relay data object between function if such capabilities are desired. When DOE is implemented in an RCRB, it is permitted to block peer-to-peer operation via implementation-specific means. Okay. I'm trying to update my mind map of this shit. Okay, so if I understand correctly, what they're essentially saying is DOE. We don't know for now if it's established between like the CPU or if it's a like VM initiated thing. So which one, we don't fucking know. But one of these two will initiate the DOE. And because it's using the configuration requests like standard, it means that the PCIe device, like let's say that the PCIe, there is one here, there's a GPU here, like they cannot do like this, right? They cannot initiate something between themselves. They need these bozos, like these guys over here, to initiate it. And then if they want, they could give the keys and the positioning to tell them, hey, bozo, you can go there. Okay, DOE is a prerequisite extended capability for function to support in-band access by system firmware/software using configuration requests to component measurement and authentication. Okay, to CMA. CMA in turn builds on SPDM. Yes, we already have a rough understanding of SPDM and CMA. Oh, nice. My music won't loop. Does VLC open music? Oh. Oh! Loop, bitch! Okay, I think it's looped. Okay. Okay, so if a function wants to have access, I think that when they're saying system firmware or software, what they're essentially saying is the VMM, right? The managers of VM, so TDX, so AMD SEV, well, it would be the SEV TIO part of AMD, so the part that actually handles PCIe for the VM. So I think that that's what they're going at there. So they're saying, if you want DOE, no, sorry. They're saying if you want functions to use CMA, you need to have DOE, because most of it happens over DOE. All right, makes sense. Okay. Yes, it is permitted to implement DOE in any type of function and in an RCRB. It is permitted to implement DOE more than once in a single function or RCRB. That would make sense because we have this image, right? Wait, did we have the... We have a bunch of things here that we could have freaking used. Anyway. Okay. Like, we have this image. We know this exists, right? So we know that we can have one device, two VMs at the same time in it. So this, like obviously from this, DOE needs to be able to be implemented multiple times per function for this to exist. All right, DOE uses term type and features with specific meaning. A data object type indicates a group of one or more data objects and can be used to determine how to further construct or parse a specific data object. Every data object includes an indication of its type. Data objects types are defined by particular vendors and distinguished by vendor ID. It is permitted for features and type defined by one vendor to require the use of features or type defined by another vendor. Okay. So the use of one vendor ID doesn't preclude you from using another vendor ID with its thing. Okay. A feature is a capability of some sort that uses data object. Wait. Okay, sorry, I wanted to make sure that I didn't fuck something up. A feature is a capability of some sort that uses data objects. a feature can be associated with one or more data object type. Each specific feature defines the mechanism used by software to discover the support of the feature. For example, by means of a capabilities bit in configuration space, or implied by the presence of an associated extended capability structure. A feature using data object must specify the scope of the specific features in relation to the functions implementing that feature via DOE. For example, if only the function itself is associated with the feature, or if function 0 of a multifunction device represent the device as a whole. I'll need to think about that again. My brain doesn't compute this. A feature using data object must specify the scope of the specific feature in relation to the functions implementing that feature via DOE. Okay? For example, if only the function itself is associated with the feature, or if function 0 of a multifunction device represent the device as a whole. Oh, okay, I think I get it. Okay. So, when reading the TDX Connect docs, so they're stating at multiple points, like some key concepts, right? They say only the TD owner can decide which trusted environment extension, I don't remember, IO device interface is trustworthy. TDI, so the TIO device interface may use DMA to access the TD private memory. And after that, TD may, the trust domain may use trusted access, TTLP, to TDI MMIO space if only the TD is the current owner of that TDI. So here, what I think that they're saying is like, we need to know what's the scope of the feature that you have, because if the feature that you have is the whole GPU, let's just think about the GPU, right? If the feature that you have is the whole GPU, well, then you cannot let like one guy have the keys to the whole GPU and the other people using like a quarter of the GPU each, like have their data read by this guy with the like master key, right? So we need to have the relation between all of these different parts. We need to know about it. So this is like set into rules. Like if you're the owner of whatever feature, let's use the right word, if you're the owner of a function, do they use function or feature? A feature using data object must specify the scope of a specific features in relation to the function's implementation of that feature via DOE. I think you have it the other way around. I think a function can have multiple sub-functions that then can have features. This is my understanding right now. Look, let's just read back from the beginning and maybe it will get in. It's just fucky because like Intel won't use the same language everywhere. This is going to be the Linux kernel 6.19 PCIe edition. Oh, look, I may still be wrong. Who the fuck knows? Let's reread it, and we'll see. Let's read it from here, because I think that's where they implement the idea of feature. Okay, so DOE uses the term type and feature with specific meaning. A data object. Okay, so here they refer to type. We know what the fuck that means. Okay, now feature. A feature is a capability of some sort that uses data object. So we're using memory for a feature. Easy. A feature can be associated with one or more data object type. Easy. That's pretty simple. Each specific feature defines the mechanism which... Fuck. Brain, read. Each specific feature defines the mechanisms used by software to discover support for the feature. Okay. So each feature may have a different way to declare to the software that they exist. Okay. So for example, by means of a specific capabilities bits in the configuration space, or implied by the presence of an associated extended capability structure. Okay. That makes sense. A feature using a data object must specify the scope of a specific feature in relation to the functions implementing that feature via DOE. Okay, so with that, what I just understand is function implements, well, probably multiple, right? Let's call it FE, right? Features. That then have relations to, they call it data objects. All right. All right. Multiple feature can access the same data object. I would assume that. I don't think if they just wrote that. Let's just read a bit. A feature using data objects must specify the scope of the specific features in relation to the functions implementing that feature via DOE. For example, if only the function itself is associated with that feature, so if only function A is associated to feature A, or if function 0 of a multi-function device represent the function as a whole. Okay, it's very simple. We're overthinking this. So what they're saying is we should know which... Okay, so our device is split in functions that are then related to features. If that divide exists, well, that divide does exist, we need to know, is that device like split? Is it something that is most likely this could be combined? Like, we need to know how the device is divided. That's pretty much what they're saying. Multiple feature can access the same data object. Like the same type, yes. But here they didn't say explicitly that one data object may be used by multiple features. It seems obvious, right? But it's not explicitly stated. Let's resume the reading. Maybe it will say it. Because here all that they're saying is features use data objects, and we need to know the scope in relation to the function, and the function we need to know the relation to the device as a whole. So we need to know the function, how they split the device, then which features are part of which functions, which then we should be able to feed that object to. It is permitted, but not recommended, for a feature using data object exchange to require that a function implement a unique instance of DOE for that specific feature. Okay, so a feature could say, I want DOE, I want that like new link. I think DOE, we need to think about it as a link, right? We need that new link, that new connection. I want it to be specific to my feature. So that's something that you can do, but they say not recommended, and that sounds logical to me. And or to allow sharing of a DOE instance to only a specific set of feature using the data object exchange, or to allow a function to implement multiple instances of DOE supporting the specific feature. Okay, so what they're saying here is it's not necessarily one DOE, one link per feature or per function. All right, we good. MB, if there's something that you think I'm wrong on or that doesn't ring true to you, tell me. It is permitted to use DOE when a function is in the non-D0 state. Fuck. Although it is permitted for a specific data object feature to restrict operation in non-D0 state. Okay, so you can use a function. I don't know what D0 state mean. Shit. Fully operational state. Okay. So you can use the DOE with a function that is operational. Although it is permitted for a specific data object feature to restrict operation. Okay, so they're just stating you can use the function when it's valid, and whenever it's not valid, well, can do whatever the fuck it wants. Okay. Sounds fair. Just want to be sure. Alright, sorry, I had some notification. Wanted to be sure that was good. Implementation note. Supporting multiple hardware software bindings. When multiple features are supported by a device, or when a given feature can be used by more than one software entity at a time, it is typically necessary to coordinate the use of the hardware-software interface between entities implementing the multiple features. SPDM version 1.2.0 introduced the SPDM connection model, addressing some important needs, but not itself addressing the hardware or software interface problem arising when multiple software entities need to maintain different context or configuration. DOE provides two basic mechanisms for addressing this type of issue. Okay. One option is that specific data object feature may require the use of a dedicated instance of DOE, particularly to allow system software to assign ownership of a specific DOE instance with the software entity using the specific data object feature associated with that particular instance. For example, data object feature A and B may perform different tasks, and so by instantiating dedicated instance of DOE for each, system software avoids the need to implement ownership control and arbitration mechanism between A and B. Okay. So what I understood from that is that if we have a fuck. Okay, if we have feature A and B, they both do different things. So we don't need to like mix them up. Like we don't have to have a fight over the whole device because those are two separate things. Greetings, Nigma. We're currently reading Special Secret PCI 7 documentation. So, if you want to be unboxing this shit, have fun. When this is done, if the underlying hardware uses shared resources to implement A and B, then the hardware may require the ability to maintain separate contexts for each data object feature, because the system software will allow the two features to be operated at the same time. Okay, so if we keep my explanation, they're just saying that feature A and feature B are assumed to be split, and if they're not, the hardware should make this clear. Or should have some mitigation for this. No, I could never do such a thing, Nigma. I could never. Oh boy, oh boy. Wouldn't that be a bad thing if this link would get shared? Oh no. I thought that there would have been a DOE for each feature. Oh, here they're not talking. Okay. I think you're making a mistake. So the idea here, DOE is each link, right? So DOE is from is from CPU or from a no, it would make more sense from a VM, okay? So from VM you have a DOE to function and feature A or B. So right now, what we're saying, all that they're saying is that yes, there is like different DOE link. We need a different instance of DOE. Like, okay, this is my understanding. They're saying having a connection to a feature on a device does not mean that you own the full device. If the hardware does not have the capability to like, well, no, the hardware should have the capability to split each function so that data is not shared. And if they don't have that capability, it should be explicit. This is what I understood from now. But yes, there is one DOE, like DOE is the link to the function. Have I missed something? If this still feels unclear, you can ask for specifications. Oh yes, I understand. Each VM device have DOE. Not if a VM access to feature, it doesn't need 2 DOE. It doesn't necessarily need 2 DOE, but what they're saying here is essentially that to enforce like ownership, like to make sure that the possible shared resources between feature don't fuck anything up, you might require to split the DOE between a bunch of features. like what we read above felt to me like if your device can only be controlled by one person at a time, don't start and make multiple DOE links for it. It's retarded. But if your device has the capability to split and share memory, then it should probably be controlled by multiple DOE links as to like properly divide these things. Because a DOE, at least to my understanding right now, shouldn't be or isn't expected to be shared between different VMs. It probably could. Like, it feels like something that they would allow you to do, but it's not expected unless your specific tool, like equipment that you're using, requires you to share between multiple VMs. Okay, let's just reread this and go down this part. Can you scroll a bit to the diagram? That's why I wanted to read this. I'll reread those two, and we'll try to make sense of this afterward. So when this is done, if the underlying hardware uses shared resources to implement A and B, then the hardware may require the ability to maintain separate contexts for each data object feature. So each type of things that we can do with it, it might need to have different contexts, so split it. Because system software will allow the two features to be operated at the same time. If you expose two features, it will allow both of them to be used. So we need to keep in mind that both of them could be executed. Alternatively, for CMA SPDM and related use cases, the optional connection ID mechanism can eliminate the need for multiple DOE instances. Typically, the connection ID mechanism provides much better scaling, and it is recommended that the connection ID mechanism be used where applicable, instead of requiring the use of dedicated DOE instances. Figure 6-38 illustrate a stack diagram where 6 applications are using CMA SPDM over DOE in 3 groups. Oh boy. How's your day, Enigma? Mine's going well. I'm starting to wake the fuck up. Object type 1, object... Okay, so we're talking about underlying data here. Ooh, that's fucky. We're using like the same data here? Do they share? We're gonna need to read more. Okay, so SPDM message is like a login message, I guess. Connect ID. Okay, when they say CMA SPDM Connect ID, I like that links to me to like a VM ID, right? So this VM as an identity that is handled by, if we're talking about TDX, we're talking about the TEE. So the TEE communicates with the device and says, hey, I have this specific ID, you allow me these features. So through one DOE link, it could be like passing that information. You wouldn't have to have multiple DOE because you could have one, and using this identity, you could like log in, interface with the thing. But if you don't have that, like if you don't have that connection ID, if you don't have that login, then you may need to be more like precise in your DOE, right? Because a DOE would then need to be linked by a feature, and you couldn't have a range of feature that you allow. Okay, that's my understanding. Mine is great, actually, because I have gotten sleep, so I can think straight for once. That's great. May I ask why you're looking at the PCIe hardware HS protocol in general? Okay, so the Linux kernel 6.19 adds the capability for well, it adds AMD SEV TIO, which is an implementation of the new PCIe standard, which itself allow PCIe link encryption. So the thing is, for each Linux kernel video, there's always like a couple of featured change of things that we go deep on, and everything else is a little bit like secondary. So right now, I've decided that this was what I was going to go deep on, and I really wanted to get my hands on like the PCIe 7 standard to have a real understanding. And I mean, goddamn, MBE had a very good idea. It was like, maybe we could like make the communication like bit perfect, fucking show how it works under the hood. Oh, that would be so awesome. I doubt we're gonna be able to like go to that level of precision, but it would be very cool. Just yeah, we're pretty deep right now. We're pretty deep. Yeah. Okay. Okay, we're going to go along, unless MB, you have any question or anything you think I'm wrong on. Yep, rabbit hole inside of a rabbit hole. It seems okay, right? Like, how I'm reading this is we have one hardware, so like one accelerator. We could have session for each of the... Oh, wait. My example is fucked right now. Okay, I need this to be explained then. We could dig a couple more rabbit hole, but we are deep enough. Yeah, we're deeping a we're digging a bit. Nigma, you're good now, okay? You're good. In each cases, two distinct SPDM. No, and I don't think I need to know that. In each cases, two distinct SPDM use case, I guess, are shown. A and B, and within each group. Okay, so A and B would be like each a function, and within each group. The SPDM configuration must be the same, but each group may have distinct requirement from the other, e.g. different hashing algorithms, makes sense. The SPDM driver and PCI driver software component must coordinate the establishment of each connection, including the assignment of a connection ID, and at runtime, must manage the transfer of data object across the DOE interface itself to ensure that multiple software entity cannot attempt to access the DOE mailbox register during the transfer of single data object. Okay, so we're just saying here that hardware needs to enforce the rule that we already have. We cannot have hardware fucking around while we're doing something. However, context is maintained in each Contain is maintained. Fuck! However, context is maintained in the device for each session. New figure illustrate at a high level how these elements relate to each other. All right. Okay. So we have different application. We have different sessions. And here we have DOE transport. Oh. So could a DOE be shared across multiple VMs? Is that what it says? Or are they like not at that level, right? Are they saying these are all like different things that we want to do with an accelerator, for example, a PCIe accelerators, and this is all from the same VM, so we send it through the DOE? Not at the level. Yeah, that sounds like it, because or else like it doesn't make sense to me, right? Or maybe they're just showing different ways to do the same thing. All right, so a data object and feature. Okay, so we have reserve, data object type, vendor ID, length, and then the full thing. All right, sounds fair. Okay, so we're just getting into like the bit thing. Also, you would also need to learn about TMDS. Oh, this is hardware thing. I don't need to care about that. Like this is like too deep. It's not the level we want. I think we're like everything that we've learned, we could explain it and maybe fuck the bit perfect thing and just explain it. Like it's already a very fun explanation to go through. I think that the new specification we are... Oh, brother, we already come from a complex land. Don't worry about it. Other than DOE discover feature... sorry. Okay, this is something that we probably should read. Other than the DOE discovery feature, DOE is used to transport data object as part of a feature defined outside of DOE itself. Okay, so you can transport data object for something that is not directly meant through DOE. Makes sense. This section defines requirements of DOE itself, although in some cases these requirements are permitted to be modified per the definition of a specific feature. Okay. Encapsulation. Oh, encapsulation, yes. Yes, that would kind of be that. Yes, I agree. For feature that define request response protocols, unless they are feature-specific requirement, a DOE instance must complete processing a received data object, and if a data object is required in response, must generate the response and set data object ready bit in the DOE status register within 1 second after the DOE go bit was set in the DOE control. Okay, so if a request requires a response, do the response. Thank you. Control register. Otherwise, the DOE instance must set a do error bit, do status register. Okay, here we're just saying like, if you're not answering my requests, we're fucked. Okay then no. We didn't look at it and won't. Hardware, we're not building, just using it. Yes, exactly. I don't think Nigma is, either Nigma is not understanding, or I know you like hardware, Nigma. I know you like talking about it. We love you. Okay. But now we're in the like higher level, more like less on the ground, more like smoking weed and saying, how many bits can you fit through that fucking thing? Once the transfer of a specific data object has been started, except in cases of error or abort, that transfer must be completed before the transfer of another data object is started. Okay. If a single DOE instance support multiple data object feature, system firmware /software is permitted to interleave data object associated with different data object feature, if and only if the data object feature allows such interleaving. Okay, makes sense. So we can see it like as if you were trying to send a message to a friend. And whenever you send that message, you say to the friend, hey, we're starting a new paragraph each time we say a word, and we have 3 paragraphs. So we add like, it's as if I was saying like, once if data the object, and like I would go like through the whole paragraph that way. Like if that's our agreed upon protocol, like who gives a shit? Alright, makes sense. All good, Nigma. Data object buffering requirements are determined by the data object feature supported, and data object feature must ensure the maximum data object size are well defined. When required, the max do length must be used to indicate the maximum length supported for a specific data object type. Okay, that feels... It feels like we don't know what the fuck you're sending half the time, so please give us at least the information on when we should call it quits. When we should say that something is fucked. Alright. Makes sense. Max Deho. Not max do. Oh, data object. True, true. I didn't think about that. But I thought about it in the same way. So I thought about it in data object size, so it's all good. Okay, it is strongly recommended that implementation ensure that the functionality of the DO abort bit is resilient, including the DOE abort functionality is maintained even in case where device firmware is malfunctioning. Yes, okay, so they're just saying, please implement your shit correctly. An FLR. Fuck. To a function. What is an FLR? Function level reset. Okay. Okay, so we're just like telling one part of the thing to reset, not the whole device. Fair. But in the video it would sound bad. I agree. I'm giving you the detail so that you get my... that my reasoning is not fucked. But when you're correcting me on these things, it's really good. Because if I don't think about it while reading it, I look like a dumb fuck. And I like your correction. Okay, an FLR, so a function level reset, to a function must result in the aborting of any DOE transfer in progress. Okay. So an FLR is like, fuck you, you're closing, no matter what, you're resetting. Data object feature must specify the ending of FLR and, as appropriate, other conditions that impact the data object feature. While an FLR is in progress, all writes to the DOE write data mailbox must be dropped, and all reads to the DOE read data mailbox must be terminated with UR. Or return all 0. Oh, fuck. Completion with UR status. Unexpected. Unsupported request. Oh, okay. Well, that would be like a dumb error to have, but I guess it's logical. Like if they implement that type of error whenever closing something often, it might make sense. If these or other erroneous action are detected while an FLR is in progress, it is permitted that upon exit from the FLR, the DOE error bit be set. Okay, so if you fuck enough while we're resetting, we might just close shop. Alright. Oh, brother, I'm the intellect now. I've read too much, okay? For the specific part that we're looking at, I'm the intellect, okay? I'm the IIQ in this shit. I've got too much. Alright, if software permits DOE operation to overlap with potential FLRs, software cannot depend on the RRS mechanism. God damn, what the fuck are these acronyms? Like, can we go to this? PCIe link encryption is made possible by the soup of acronym mentioned in the short log below. This is so true. Yeah, has a filter on his wing after just side by side. Because it's so large. It's so fucking large. True. The IQ is so hard. Okay. What the fuck does RRS? Request retry status. Okay. And FRS. Bro, I was about to reread this one as FLR. FRS, what does that mean? Function ready status. Okay. Hang on. If software permits DOE operation to overlap with potential function level resets, software cannot depend on the request retry status mechanism. So I guess that's kind of a default way that normally PCIe does like waiting on something to reset, but rather must use a time-based mechanism or FRS. So FRS would be the function ready status. So function ready status to determine the completion of an FLR. Okay. Okay. DOE errors cover errors in operation of DOE itself, and, except as noted below, do not extend to errors associated with data object features. Any of the following event must result in a DOE error bit being set: a poison configuration write to any of the DOE registers, overflow of the write data mailbox mechanism. Optionally, if the associated data object feature does not provide an alternate mechanism for reporting such errors, the transfer of the data of a data object that is shorter than the minimum expected length of that data object. Okay. All right. Okay, so that's the we're talking about errors here. I don't think it's interesting. Like we understand. If it's too short, doesn't work. If it's too long, doesn't work. If it's fucked with, doesn't work. Error or manage. Easy, right? Like maybe this will give us some details. So let's just read a bit. Exchange of data object data. Object. What? Exchange of data object. Data objects are exchanged through the mailbox provided by the data object exchange extended capability. The DOE mailbox is defined to flexibly support a variety of data object. And as a result of the definition of specific data object and their associated feature, it is necessary to provide the information required for the requester and responder to appropriately size their data buffer and robustly implement the associated feature. Alright, so here all that we've said is make sure that you have buffers when you request something, retard. At the level of the individual DW, downward. Fuck. Request address? I guess request address. Okay, let's read to see if it makes sense. Okay, at the level of the individual request address transfer, the DOE responder can use the completion for the DOE mailbox configuration read and write operation as a flow control mechanism. It should be understood by hardware designers, however, that delaying configuration completion will typically stall the software operating DOE. Fair, and in some cases may also cause stall in other software hardware operation. Okay, so what we're saying here is that okay, whatever manages the VM and DOE for your hardware will rely on the configuration completion to know that something is done. Please, for the love of God, set your bits. Okay, cool. Okay, this is all like the same shit. Alright, we're back. We're back. Alright. I think we were here. Or, nah, we were deeper. How's it going so far? What do you mean? Having a headache? No, that's like yesterday I went through this, okay? So to me, it's getting more and more like obvious how this will be implemented. And how it is currently implemented because the Xeon 6 have this, this technology on board. Or at least a large part of this shit. Well, my friend, maybe I would have become an hardware engineer if I took my meds earlier in life. But right now, I've got a daughter and I'm fucked, okay? So I'll be a YouTuber. So yeah, that's where we are. Alright, I think we were like somewhere here? Or were we down? No, we were not down here. We were here. Let's read this. I need to make a video about that whole fucking shit. It would be so good. God, we're never... We need to get kernel info done. We need to get that shit done. We're so close. We're so close. Correspondingly, a device controller can support CMA SPDM in multiple ways, depending on the associated form factor and platform requirements. An implementation choice. For maximum flexibility, it may be desirable to support all of the following. Out of band, over SM bus, I2C, I3C. So we use their standard to communicate. So whenever we want to do a communication, we can do that communication that can still be secured, that can still use the same element as PCIe, but outside of PCIe, if we use the right standard to do so. We can do it by using the same communication I've just talked about, but encapsulating it into a PCIe message, or we can do it through the DOE, which is what they're saying here. So we can do it through a DOE, which is the main, like, preferred secured way to do it. Or when the requirements for a specific implementation does not require this level of flexibility, it may be preferable to only support one or two of these approach. Yeah, that's pretty obvious. The platform requirement for CMA SPDM are determined by the use case supported. Example use case that apply to add-in card as a unit include before platform boot, management controller checks the add-in card out of band. During the platform boot, the system firmware checks the add-in card in band via DOE. During runtime, a management controller or system firmware, software firmware check. So remember, this is a VMM, this is TDX, this is a AMD SCVTIO. So this is like our VM manager. Checks the add-in card via MCTP VDM. Oh. So this would be initiated. Like, it would be initiated like this, right? It would be it would not be through DOE. What is this? VDM transport binding. The management component transport protocol over PCIe VDM transport binding defined transport binding for facilitating communication between platform management subsystem component over PCIe. Okay, what the fuck do they mean by VDM? Oh, bro. We're not defining shit here. Vendor defined messaging. Oh. Oh. Well, that actually makes a lot of freaking sense. So, like, something that I said at the very start is that, like, maybe I said it or just in my mind. Like, from my understanding, like, TDX will have their own way of communicating, like, 2D hardware to PCIe. Like, of course, it will use, like, DOE, it will use all the PCIe standard feature, but at the end of the day, the hardware itself will need to implement something TDX branded to communicate and to do the proper, like, DMA operation on TDX branded memory, right? And same thing with AMD. So I think that what they're stating with this is that your branded hardware will probably have a way to identify itself, have a custom way to, like, say hello. Enigma, we're talking about this was released in June, and it's not public, right? So we're talking about, like, frontier knowledge for how TDX, how TIO will be handling their communication. This is why we need to parse through this shit, because or else we just have the abstract knowledge that comes from the TDX and TIO like documents, which are very limited, right? Because keep in mind, if you're Nvidia, you have access to this. If you're Intel, you have access to this. But if you're trying to sell your TDX chip, you don't have to go in that level of detail. You just have to say, like, look at the fucking PCIe 7 thing, do this, and then fit with us. So, the example doesn't specify if this is for encrypted access to the device. Yeah, for now, okay, yes, for now we're not even talking about encrypted access to the device. We're talking about generically, like, starting the communication with the device. Or communicating in general with the device. I'm just stating that this probably makes a lot of sense. I guess there would be a DOE mailbox, even with a VDM. Wait a second. Like, I'm like only thinking about boot during runtime. When they say add-in card, do they mean like plug and play? Bro. I guess not. Okay. Okay, MB, let me just, like, beam shit into your mind. My understanding of this is, like, for detection, right? So TDX would have to send in their private language, like, hey buddy, who are you? What do you do? And then it could, like, expose this to the let's make a drawing. So the TDX technology offers something called the TEE. So the TEE is a secured part of your CPU that is considered always trustworthy, that manage the VM. So the TEE, what it would do is it would do that communication, right? So it would do the check on the card, say, hey, what the fuck do you do? The card would answer, I do these things. So it would answer back to the TEE, I do these things, and then the TEE could say these things to the VM, right? Could say to the VM, hey, we've got these, well, okay, VM. We have these capabilities, right? So when I see this, I feel like it's more, what the fuck can you do? Or management side of thing done by the TEE, the secured part of the CPU, but then communication would come through DOE. But I guess I'm extended. I'm overextending, maybe. Because it's not explicitly stated. Please check D without showing it on stream. No, I don't need to. Because, if it was an image, like just an image, I would be stressed. But just this, not really that scared. But you've got it on your side? But do you have it on your computer, Nigma? Alright. See? All problems solved. It makes sense. We don't know the feature which we would connect beforehand. This is just the initialization. Yes, this would be my idea. Because here they're specifying that it's for the management controller and system software firmware. When they say system software firmware, it's code name for TDX. It's code name for SEV. So this is... like, I feel like they would probably make it explicit that we're talking about a VM or a specific... They would make it more explicit. That's all I... Okay. To support use cases where the management controller and system firmware software communicates the result of their checks with each other, it is necessarily that the result of those checks be consistent, subject to any change applied since early checks were made. It is for this use case that function 0 requires to match identically the results received via these other mechanisms. Okay, so I'm assuming here that when they say function 0, they mean the whole device. So all that they're saying is no matter how you communicate, no matter how you initiate something, the result should be the same. Which sounds fair to me. For use cases where the add-in card is being evaluated as a unit, the device controller can, through implementation-specific means, attest and/or measure other board elements to ensure that the identity and integrity of the add-in card as a whole is correct. How this can be done is outside of the scope of CMA SPDM. Okay, that makes a lot of sense, right? So, let's say that you would want to make sure that the accelerator that you're connecting to has not been trafficked. It would be the purview of TDX through their trusted environment, through their DEE, so the specific part in the CPU. It would be their purview to confirm, like connect with the chip there and be able to say, hey fucker, this is not what I've ordered, or yes, this is a valid thing, you can store your shit here and it will be correct. For improved interoperability, CMA SPDM requires support for certain algorithm, while allowing support for any of the algorithms supported by SPDM. Flexibility is allowed for responder algorithm selection with the intent that the device vendor can, if desired, align their choice with common standard such as those defined in the Commercial National Security Algorithm Suite and in NIST Special Publication 800-57. The application of CMA SPDM are numerous and varied. For complex environment, the issue of secure identity provisioning, measurement collection reporting, and verification of attested state may require evaluating additional standard and industry best practices. Examples include TCG reference manifest, OCP, okay. Okay, so I feel like what we've just read is if you follow CMA SPDM, you will get from one place to another safely. Or at least it will follow like this protocol. But it doesn't ensure anything at destination, right? If your GPU is like a threat GPU, of course there's nothing that can be done without something external like TDX going through it. You won't have segfaults trying to talk to something that doesn't exist. True! Okay. An overview of threat model. Maybe there we'll get a little bit more of an idea. A detailed threat model analysis typically requires consideration of the context in which a system is operating and the composition of the system along with many other factors, and as such cannot be provisioned here. A high-level overview of the type of threat for which CMA SPDM may be applicable include remote and local software-based attack, e.g., to install corrupted device firmware to roll back device firmware to an older version, threats from attacker in physical possession of the device, including software-based presentation, so that would be the like fake GPU thing, hardware attack. So I guess reading the data that passes through the PCI. Attack during manufacturing, provisioning, or maintenance, including provisioning of improper configuration or firmware, improper repair of a module. Okay, so if you like were to split off the TDX module from your CPU, you're fucked. Alright, CMA SPDM requires the leaf certificate to include the information typically used by the system software for device driver binding. This requirement is intended to support scenarios where the attacker device attempts to gain access to system resources by appearing to be a valid device type. Responding device can include this device serial number value in the leaf certificate to simplify system implementation of policies that require specific unit instance to be identified. For example, to support scenarios where a modified unit is substituted for a valid but otherwise identical unit. Alright, so we're just saying, like, check your shit. I don't know if it's that special. All right, we're getting into the rules. Oh, after that we're gonna have that to read. That will probably be the fun part. It will probably confirm a couple of things. I'll go take a leak. I'll be back in a minute. If you have any question, I'll answer them. All right. It is like I said yesterday, physical access bypass most security protocol. And the owner of those, I think that's where the disagreement comes in. This is what TDX is trying to fix. So the idea, maybe you already know, but I'll yap anyway. The idea is TDX, whenever you whenever you install a kernel-enabled TDX, it's supposed to be able to detect a signature that only TDX-enabled CPUs are able to do. So that way it can know that the CPU is not like a fake one. And like, that's just like HTTPS, right? You cannot fake the signature of Google, right? So that's how HTTPS work. TDX works in the same way. So the idea is if you can have this like root authority of TDX, then if TDX is able to check the authority of other things on your system, you're able to extend this security, right? So if you have, let's say, a chip on your GPU that would be able to look, I'm not I'm not smart enough to know how they would do this, but that would be able to check the integrity of all the memory chip. That would be able to make sure that it, like the chips themselves, cannot be read as they're used, and these types of things. Then technically you have a zero trust environment, right? The only way that you could break this would be to literally break the TDX signature, which in our current world is impossible. So this is the idea of SEV and TDX. It's to destroy this thing of saying, as long as the GPU... No, that's the thing, right? Let's say that the GPU is compromised. So the idea is that in the same way that we can know that we can check the identity of a CPU, I don't know how they do it, okay? But they probably can check the identity of a GPU. And they would maybe be able to do a bunch of tests, know that if the latency, the specific latency on the memory chip are not the same, or like I don't know how they would like diagnose this, right? Or maybe they can like beam into the memory chip some signature on it, and like if it changes from manufacturing or something, like it would fuck up. I don't know, but there's surely a way to do this, right? That would make it so if there is change to the hardware, it would fuck it up. So it would allow TDX to check whatever the fuck it's looking at and to say, okay, this GPU is inside of our pre-approved list. It's part of the one that we are saying yay. So because we are saying yay to this, then we can detect if it's compromised or not. We can make sure that it's not compromised and then go on. Right? The whole idea here, well, not here, because here it's PCI Express, it's out of this. Yes, the GPU would have to be TDX compliant. That's the idea, right? So whenever they talk about, like I had this feeling, I will need to like read this back, but my feeling through reading Intel TDX Connect was your device needs to be compliant, and if it is, then we would be able to check, right? And at the end of the day, throughout this whole thing, it says, well, okay, the device under a PCIe root complex could include a TDISP compliant and or regular PCIe device. A TDISP compliant device could host one or more TEIO device interface, TDI, which could be assigned to a single TD at any point in time, or alternatively a regular device interface. Okay. So if we go look at TDISP, we will probably see that it means, like, we have verified that shit. We know what the fuck this is. Somehow. It's probably up here. This sounds like an insane thing to... Fuck, it's not here. Bro. TDISP. Oh, whoa! You're saying that it's... What? Does that mean that I'll be able to search it? 973. Fuck. TDISP. Ooh! What? Oh no, it's the page that I don't have! Bro, we're cooked! No! We're so cooked! Okay, so maybe this is way more implemented inside of that standard than I thought. Approved. TDISP. PCIe. Okay, the IDE and TDI, can we have a real, like, fucking explanation, or just like, we're memeing, Okay, that's a meme explanation, thank you. Memes. I think I was wrong in one of my assumptions, but maybe not. We don't know yet. We don't know. Goddamn. TDI-SP message uses a specific set of message by CMA SPDM over the... okay. Okay, so TDISP... Okay. Okay, I'm getting it now. Oh wow, that pushes back my understanding of this. Okay, let's go back to this image, just so I can put MB on the same point. Okay. Oh, do we have something in there that, like, ID spec? TDI... Oh! Click, bitch! Bro! Go fuck yourself. Is it going to be the thing that is, like, non-downloadable and... Bro... Bro, no! Ooh! No! I don't want to go back to China. We're far from plug and play here. Okay, here's my understanding, just to share it with you, MB. So... Okay. Okay. So my understanding... Have you looked at the... Have you looked into the ideas for the document? Hi? I don't get what you just wrote. High seas. Is this a joke? Or is this like a website? Oh. No. The problem is, this is all under previous spec, right? If I had a full version of the version 7, I would be good. But my version, well, I'm going to show you where it's from. Not my history. That's my version, baby. And the problem is, it maxes out at page 1000. Or maybe I can... Look, I fucked this shit up a little bit. I know how this shit works now, okay? Okay. Let's try to go deeper. Ah, shit. It's not just the PDF viewer that's fucked. Is there a part 2? Oh. Bro, the source of this is already cringe. Like, you cannot log in because it's Baidu, it's Chinese internet. Wait a minute. Wait a minute. Bro, if we had the second part. If we had the second part. Oh, we're so unhinged. But yes, the PCI E7, I've checked everywhere. It doesn't exist. Where the fuck did I find this? Okay, I guess that's the same one. Oh yeah, that's the spot. That's the spot. Wait, we're in. We're back. Oh fuck, he doesn't have the Ooh. He has an older one though. Bro. I'm about to live Zinhu. Alright, brother. Right, brother. Alright, the fuck does that? I swear I'm Chinese, guys. Bro. Ooh, download link. Wait a second. Can we have a real download link because the Baidu one are fucked? Oh shit. Full text download. Okay, that's the 4. We have the extraction code, so we'll need to do the dumb fucking shit I did last time. Yeah, and it maxes out at 1,000, which probably means we don't have everything. What a fucking valueless proposition this is. What the fuck were we talking about right before that might be in the 6? Bro, I don't even remember what the fuck I'm thinking. And this shit is slow as shit. I think we're getting there. We're searching for TDI something. We've got more IDE stuff, but... Well, maybe we've got a little bit more in here. Although I don't want to waste my fucking time. It took me so long to download all of this shit. Alright, we're fucked. TDI ain't in here. It's way later. No. It's not a file, it's multiple image. I know, I just did it in front of you, but maybe you didn't see. So, here, there's the link for the actual file that we have access to. And... oh yeah, that's an expired link, but... The link, no, you need a Baidu account, and for that you need Chinese citizenship. Before it was possible to, but now it's not. So I'm kind of screwed. Lol. Okay. All Alright, let's close a couple of things. Okay, so just to go back, if you're still there, MB, here's my new understanding. New understanding. Understanding update. So the idea is I thought that the only thing that was the purview of PCIe was the connection, like this part. But I think that the purview is in reality like this. So like the inner management of it is still inside of PCIe, and maybe like confirming that the device is valid, that would be TDX, right? But ensuring that we have a state, that we have like that we're able to send VM information, and that we could have an update from the device, and that like all of these things would be the purview of the PCIe standard. Ah, Enigma. Invasions of privacy? Who cares? You'll find somebody that doesn't care about privacy in Maple, okay? In me, you'll find a bootlicker. So, yeah, because in my thought, like the only job was to connect, right? But not to handle VM state. But TDI, the standard, seemed to have implementation of, hey, am I online? Right? So like TDI SP state machine, like this would mean to me that some of the code that handles what happens once on the PCIe is once on the PCIe accelerator or the PCIe device is still handled by this. Anyway. I'm better to go in the other sense. Yeah. Yes, I'm not saying the full VM, but... Okay. Maybe in my mind, way less of it was on the PCIe standard. But it seems that the PCIe standard governed way more than what I thought. That's pretty much where I'm at. Oh no. Oh no. Oh. Bro. That ain't it. That ain't it. Okay, I don't know if we need to dig any deeper. I'll just scroll down to wherever the fuck we were. Whoops, I'm past it. And we'll read a little bit of the secured part. Oh, okay, so that explains it in detail. Shit. Yeah. I think this is where we should, like, cut the scope. Alright, let's just read this real quick. Oh, we're talking about multi-billion dollar, like trillion, trillions of dollar, like that these standards are going to govern. So whoever is writing this shit is getting paid a fuck ton. Secured CMA SPDM provides security for data object protocol based on SPDM mechanics, including IDE key management, IDE key M protocol. Once a secure session has been established per SPDM, it is permitted for some uses required to use a secured CMA SPDM to transfer other data object with integrity encryption using the algorithm negotiated in the SPDM session management per secured SPDM. It is permitted to continue to perform non-secure CMA SPDM operation after a session has been established, provided the specific use allow for non-secure transport. Secure CMA SPDM data object must be formatted per secure SPDM. It is permitted for specific data object protocol to constrain the use of content of optional field. Okay, so they only go like into make sure that it's not obvious from the outside that what you're sending is what you're sending. Use these things. All right. All right. Well, one mistake, $10 million down the drain. I don't think about it like that. Like, they can do revisions and shit, but like they're just going to, like, it's people that that spend their lives doing this, right? It's what they love, it's what they do. So, makes sense. If it's what you love doing, then do it. Alright, alright. I guess we read TDX. And then we read AMD, SCV. And we should have a good idea. Alright. I don't know where I was with this. Well, yes, yes, Nigma, but that's because you want to try to be like a one-man army, right? If ever you do something alone, you cannot leverage the performance of having the best of the best near you, right? The people that write these docs, they have on quick dial, okay? They can call the dev that is actually implementing this shit. Right? They can call the guy that actually made the lines on the silicon. So, yeah. All right. did we, MB, did we read any of this together? I think that, like, I explained this, but... Fuck. No. Alright. I'll read it from the start. I don't think that this part is interesting. Yeah, they're just going to say like, oh, we're explaining what the fuck we're doing. Okay. I didn't hear it, but you can read the resume. Yeah, that's true. There's no need for this shit. So we're just going to reread the resume because it does it. Okay, so let's do it. Now let's take a moment to understand how communication between PCIe device and secured VMs normally happen. In a secured VM, the memory of the VM is encrypted. This removes our ability to ask a PCIe device to read the VM's memory directly through DMA. This forces us to use software I/O virtualization of the PCIe device. The host will supply the VM with a shared buffer that will then be used with the PCIe device. This is slow and untrusted. In the event that the PCIe device, let's say a GPU or an accelerator, doesn't have encryption-decryption capabilities, it would also force us to leak the information that we send to the buffer, the information that we want to process. So this is the TLDR. Yes, we're supposed to explain all of that shit. That's the goal. All right. So now we have that understanding. Okay, just in structuring my video, I'm trying to brain here. Maybe going into specifics might be an issue, and I should generally like lay out how PCIe work, or maybe it's going to be too boring if I do this. Anyway, let's read a bit of TDX. Let's read a bit of TDX. Enigma, are those questions? Or if you want me to answer them, I'll be happy to. Why would the protocol need a VM? Software layer isolation. Okay. Nope, just summarize it. Okay. I'll still answer it. That's not the goal. So let me give you the image. I'll explain it to you because it makes sense. So the idea is that normally you have to transfer the information into a buffer, then send it to the device. The buffer can be read by the host, which the host may be malicious. So the solution to this is to have an encrypted link and a trusted device. So that's the idea, right? It's to make sure to extend the trust compute boundary of the VM. So let's read this shit. That's the most interesting part. Base Intel TDX hardware prohibits device from directly accessing trust domain private memory. Therefore, only software-based I/O virtualization is supported. The untrusted hypervisor exposes a virtual device, such as a network interface controller, NIC, to a TD, I cannot say that, trust domain using shared untrusted synthetic I/O and para-virtualized device interface managed by the VMM, so Virtual Machine Manager. The software-based I/O model is slow because the communication between the trust domain and the device is done through shared memory bounce buffers, which requires the trust domain guess to copy and encrypt back and forth the data between the private memory buffer of the application running inside of the trust domain and the shared I/O buffer used by the device. For some I/O use cases, such as networking and storage, trust domain may employ software-based cryptographic techniques for data protection. However, this approach may suffer from performance overhead versus VTD direct I/O virtualization, low latency, high throughput. So this is the way that we used to do this with a VM that is not encrypted. Now with the one that is encrypted, we have a bunch of dumb overhead that we have to do. Besides the performance overhead, the cryptographic data protection does not allow the trust domain to offload computation to legacy GPU or FPGA accelerators and requires them to be in the trust compute boundary of the trust domain and properly protect its secret data. So, yeah. We need a solution for sending shit to GPUs and FPGA. That's the TLDR. Anyway. I/O virtualization with Intel TDX versus Intel TDX Connect. Intel TDX Connect is designed to improve I/O virtualization for TEE. So TEE, remember, it's the CPU part that handles the VM. Can we just have the fucking real name for this? TEE. Trusted Execution Environment. Thank you. Functionality. Removes the need for the trust domain and devices to use shared buffer for private data, including the need to establish a secure transport level session with the device, typically done through proprietary protocols to adjust specific device data processing and transformation needs. Performance. Removes the additional resources and work needed for the data copy encrypt or copy decrypt back and forth between the shared TD device buffer and the private TD memory, greatly improving the workload performance with respect to bandwidth and latency. Intel TDX Connect architecture introduced trusted device assignment to a trust domain, extending its trust domain trusted compute base, and to a TEEIO interface, TEEIO device interface, TDI, fucking hell, while protecting its data in CPU, extended Intel TDX hardware while private MMIO and DMA access control and data isolation, transport, end-to-end data protection using PCIe selective IDE streams, devices, extending the TDX module with SPDM, IDE, TDISP support, allowing trust domains to extend their TEE and TCB only to TEEIO devices that they choose to trust. Okay. Well, you want to know what's fucking cool? Is a lot of the encryption in these in these CPUs are made so that they have either no cost or like next to no cost. They are unhinged, okay? They are unhinged. It's crazy. You have to rewind a bit the video. Well, it depends. Right, that's where we're going, right? We're going to a place where encryption is good enough. And this is it, right? TDX is already able to encrypt and decrypt the memory that's being sent to the CPU and shit, this is already something that it can do, like, as fast as it would without. Or like talking about like one instruction behind, which we don't give a shit about at that point. All right, so if I wanna TLDR this back to life, okay. If I want to TLDR what we just read, right? So let's TLDR all of this. So what we're saying is we're saying, one, we do not need, let's paint a bit. We won't need the shared buffer anymore because we will be in this world. So we will be in the world where we can have a direct encrypted connection with the PCIe device. That's first thing. Second thing, the CPU will also be able to offer DMA to the device. So the device will be able to look directly at the fucking data, if of course the host allows. That's another thing that we have. The data is encrypted while being transported. What else? So we have a gain in performance there because we use DMA for the data. We don't have to trust the host. Pretty much where we're going, right? I don't know. Am I missing a thing? I think I got it. Like everything makes so much sense. Explain the bridge thing. The bridge here, they're talking about like South Bridge, North Bridge. So I think it's South Bridge, the one that we're thinking of right now. We're talking about a PCIe bridge. So the goal of the PCIe bridge is to split, let's say, a 16x port into multiple other ports. This bridge is technically never trusted, but it never has access to any data because the only thing that it has access to is where the data goes. So it's a little bit like a switch or a router that you would use for like networking. Here, it's going to be called a bridge for PCIe. I'm not sure I understand what you're saying, Nigma. I'm sad about how people like rewrite history about AMD, especially. Like all the people that are like, "Oh, AMD always was great." And it's like, maybe you're a bit young. That feels dumb, right? Or people that wanted like AMD to die, that was dumb too. Just as much as people want Intel to die today, that's dumb as well. We need to have competition if we want shit to work. And the fact that Intel is waning right now is sad. Alright. We need more, not less. Exactly. Like architecture, CPUs, and these kind of thing is something that we want diversity in. It's not the type of thing where having one person control everything is a good thing. Two generation verification process fricked. Well, I don't think there's any. Well, to my knowledge, there's no human error there. The issue is just that, like, okay. I don't want to go deep into it. I'm just going to explain this so that you can see my point of view, Enigma, and if you don't like it, that's okay too. So my understanding is that you have two people that were able to make silicon. That's my example, okay? There's more, but who gives a shit, okay? So you had Intel that had their own, like, capability to make silicon, and you had TSMC, Taiwan, right? So you had Taiwan, you had Intel, and the problem that happened is that Intel fell behind. Even if they had like the superior architecture, they had everything superior to AMD, they fell behind in like how good their silicon was. So everything that they made was shit compared to TSMC. And because AMD just went to TSMC to buy their shit, and then like, I'm saying TSMC, but there's another one I know, but who gives a shit? Just went to TSMC to make their CPU. They gained so much fucking thing from the fact that TSMC is absolutely trouncing. They're like winning on every front compared to Intel. So the superiority is not really AMD's, it's TSMC's, and the fact that Intel is not able to match whatever the fuck is going on here. And the problem is that the big superiority that Intel has was its production, was the fact that it could in-house do everything. And now it's his biggest weakness, because you still have to do a bunch of research, right? There's the cost of research that comes from Intel that TSMC is still paying, right? But TSMC doesn't give a fuck because it's offering this research to AMD, to Samsung, to all of these other people, while Intel is only for their own bullshit. So right now TSMC is trouncing Intel, and Intel is fucked. All right. I don't care about that, Nigma. Love you. Made an explanation and deal with it. That's why Intel has a hard problem right now. Okay. System overview. The OS platform hardware may include one or more sockets each, with multiple cores, memory, controllers, and I/O hubs. The cores and the I/O hubs share a coherent system cache and fabric, which is connected to the system memory with memory controller implementing Intel multi-key TME encryption engine, right? So this is why the PCIe can go read the RAM, is because this bitch does the work and this bitch can talk through the coherent fabric. Each I/O hub includes an IOMMU related logic for connecting devices to the coherent fabric within the SoC. A subset of each of the fucking hell. A subset of the I/O hub may include PCIe root complexes, and that they are used to connect discrete PCIe devices, while others may only support within a package integrated device. Okay, so you may have an I/O PCIe hub. Well, you may have an I/O hub for the SoC itself and an I/O hub for the PCIe. Makes sense. The integrated device are not included in the Intel TDX Connect scope, while a subset of the discrete PCIe root complex I/O hubs have Intel TDX Connect support with bifurcating RPs. Root port that may support PCIe IDE extended capabilities. Okay. Okay, that makes a lot of sense. So we're saying that these I/O hubs that are integrated, they don't need to be part of the scope of Intel TDX Connect, most likely because like that part is not said. The part that I'm saying right now is not said. Intel TDX already takes care of these, right? They probably already have some integrated feature for managing Intel TDX, but in Intel TDX Connect is therefore these things. So the root PCIe that go outside, that's the one that Intel TDX Connect is trying to fix. I should have a permanent clipper, okay? If I was a full-time YouTuber, yes, I would have a clipper. Somebody fucking making shorts out of my explanation. Alright. Intel now uses some other fabrication people. They do orders. So I believe Intel does use TSMC sometime now because of how fucked they are. But like, I don't think that anybody is blaming TSMC. I just think that, like, they're just better, right? I hate shorts. Shorts are evil. Yes, shorts are, well, like TikToks, like Instagram, whatever. Reels, I think. Like they work a lot for ADHD adult men, okay? Trying to stay away from it. Like, there's nothing bad with a company making their best. That's Intel, that's AMD, that's TSMC. They're all good people. It's just, like, a sad situation. Each PCIe root complex may be connected using bifurcated PCIe link downward root port to to the endpoint device directly or via any topology of bridges and switches. Okay, so we can use bridges and switches to like send shit because IDE already secures the connection, right? We don't need to trust the bridge to send information through it, just like a router. The device under PCIe root complex could include a TD-ISP compliant and or regular PCIe devices. A TD-ISP compliant device could host one or more TEEIO device interface, which could be assigned to a single TD at any point in time, or alternatively, as regular device interface, which can be assigned to TDs via shared memory or to regular VMs. Okay, so they're saying whenever you have this enabled, it does not mean that you're not going to be able to like use your old cards. If you enable it, it will work. You can have an entire device for one person, or you could have an entire device split between two person, if of course it allows it. All right. The platform system software resembled that of the platform with TDX support. It includes an hypervisor that may host one or more VMs and may include an installed TDX module with Intel TDX Connect support. Okay. Not sure that I get the point of that. Did you get a flashback? Yes, because I read this a little bit earlier. Alright. Intel TDX connection security model consists of the following key concept. Only the TD owner can decide which TEEIO device interface is trustworthy. TDI may use DMA to access TD private memory only allowed if the, I'll say trust domain, if the trust domain explicitly allowed it, and only while it's exclusively assigned to that TD. Okay. Okay, yes, of course, you shouldn't be able to access like your internal memory of the trust domain of the VM if you're currently controlled by somebody else. That would be unhinged. TD may use trust access, TEETLP, to TDI MMIO space only if TD is current owner of that TDI. Okay, so in other words, you can read the memory using MMIO, which is what will read the memory, let's say, of a graphic card, if you're the owner of the thing. That's pretty easy. Promox will need to support it or provide a module for it. Promox would be able to... Proxmox would be able to manage this using using host command. So like, we remember that TDX, the goal is not to remove all control over the VM. The goal is to restrict it to the TEE. So you have some central TDX host command. So the host can use these host command to effect some change that will go through the TEE, which is the secured part of the CPU that handles the VM, and then it will affect the change on the VM. It's just that these commands are limited, where before, of course, there were no limitation because VM was strictly in the purview of the hypervisor or of its host. Here, it's in the purview of the TEE, which is restricted by whatever the fuck is inside of that list, right? So we know that it can move memory, it can page memory, it probably can ask a VM to close, I guess. But like, this limits the amount of action that can happen. So Promox would have to implement these in order to control the rest of it, which I'm sure they've already done. This technology is out for long enough. Proxmox has it. Oh fuck, did I not understand something? Where did they talk about hypervisor? It includes hypervisor that may host one or more VM included. Oh, okay, I understand. Okay, the platform system software resembled that of a platform of the TDX support. Okay, so it says you need to implement support for the TDX Connect in order to make your shit work on the part of the hypervisor. Got it. All right. All right. We agree. We agree. We're fucking big brain, okay? You're my new source of white noise. Love to be that source, okay? We'll see each other in 5 days. Okay. Let's resume this shit. The Intel TDX Connect trust model require each trust domain to explicitly accept a device into its trust boundary. Device being trusted by one trust domain does not imply that it is in the trust boundary of other trust domain that have not accepted the device into their trust boundary. Okay, so the trust domain is the one deciding. The VM is the one deciding. Makes sense. According to TDISP, such a device is in the trust boundary of all trust domain that have accepted it into their trust boundary, and it must maintain per trust domain isolation per TDI. So TDI is like the connection, right? It is the interface that you go to. And of note, according to TDISP, remember TDISP, even if it contains TD, it's not Intel. That's PCIe standard, right? So when they say this means that it is handled by the PCIe standard. By following it, we have that. So, of note, Proxmox VE 9.1 released on November 19, 2025 include initial support for trust domain extension. Wasn't that long ago, and it's not a complete support. Surprising, because TDX has been 2 years that it exists. It's just that it was implemented for like Google only and on like one CPU. So that's why we like the full release was last year, right? So like 2 or 3 releases ago. Surprising that they haven't got their shit in order faster. Enigma. Oh my god. Okay. A single TDI cannot be shared between trust domains. Wait, what? Okay, when they say TDI, do they mean the port, or is this just another way to say an IDE stream connected to a thing? TEIO device interface could be assigned to a single... Oh, okay, so TDI is their word for function. Okay, I got it. I got it. It's their word for function. VMware was in June 2025 only. So, when they say TDI, it must be written up here. They really just mean function. T device interface. Unit of assignment of an I/O virtualization capable device. For example, TDI may be an entire device, a non-IOV function, or... Okay, yep, that's it. That's it. It's fucking function. Okay. So remember, device can be split into function. TDI means function, means connection to a function. God damn. We're big braining this shit. Okay, let's reread this. A single TDI cannot be shared between TDs, however, a multifunction device supports multiple TDIs, can be trusted by multiple TDVMs, and use a single IDE selective stream to secure the data path between the CPU host and the TEEIO endpoint device. Okay, so that would kind of mean... Okay, so the ID... But that would by default void your protection. That's unhinged. Are they saying, like, if you don't care about security, we can use, like, one big-ass IDE? Function zeros the whole device. Yeah, but they're not necessarily talking about function zero here. Don't remember. Okay. Let's reread this. A single TDI cannot be shared between TDs. That makes sense. Okay? A single function cannot be shared between trust domains. We know that. However, a multifunction device that supports multiple functions can be trusted by multiple VMs, by multiple TDs, and use a single IDE selective stream to secure the data path between the CPU host and the TEEIO endpoint device. That makes no sense. How can you have multiple VM use the same stream? Wait. They're cooking. Okay. So you've got CPU. And in the CPU, you've got the TEE. They're cooking, okay? You've got the TEE. So what they're saying is we cannot trust the host. So what the VM can do... Whoops, wrong place for this. What the VM can do... So let's say we have multiple VM, VM1 and VM2. And they each do function 1 and function 2 on the PCIe device, okay? Because this is split, right? We read in the specification it needs to be split, right? If you have two functions, you shouldn't be able to mess with each other's data. What the VM can do is they can each request from the TEE independently to connect to the PCIe device. Now, the TEE, what it will do is it will create a secured link, the IDE link. So the IDE link is just there to protect against hardware or host directed attack. So of course it does this, right? Because it is encrypted, but there is no possible attack that could come from VM1 or VM2 coming from this, because the TEE is in control of the communication. So this would mean that the TEE could, in one session, in one type of encrypted communication, send the two requests under the same umbrella, under the same IDE. I think that's where they're going at. Let's go forward. Intel TDX Connect TCB, trust cosine boundary, does not include switches and bridges. Yes, so the switch and bridge itself is not considered safe, but we don't give a shit. Therefore, it is a requirement by the host VMM to set up selective IDE stream to guarantee end-to-end IDE protection between TDVM running on the host CPU and TDI running on the TEIO device. Okay. So that would probably say that if my graph is unsafe for a specific reason that we wouldn't know, don't do this, right? This is what I understand from this. Maybe this will be explained, but let's just read this still. That fit with the earlier graph we saw. Yes, but we're going to see this, right? The below graph illustrates the Intel TDX Connect trust relationship in which the TDX Connect... Let's lower this beforehand. I'm not looking at the graph right now. Fuck. Okay, I'm not looking at the graph. The TDX Connect host platform and TSM... Fuck. What is TSM? T Security Manager. Okay, so the rules, the policies. Okay, yeah, okay. So policies that are enforced by TEE. Okay. The TDX Connect host platform and TSM are trusted by all TDVMs. Okay, so we trust TDX. That's pretty default. Device 1 is trusted. I'll look a bit at that, okay, instead of not trying to get my ass spoiled. Okay, so VMs trust TDX. Fair. Device 1. Where the fuck is device 1? Okay, that's the one. Device 1 is trusted by both TDVMs, since TDI VM1 and VM2 are assigned... Oh, VF, okay, virtual function, or, yeah, probably. Okay. Are trusted by both VMs since the first function and the second function are assigned to VM1 and VM2 respectively. Okay, so VM1 is assigned to this, VM2 is assigned to this, and here we see IDE stream 1. They didn't say 1 and 2, they said 1. That means that this bitch ensures safety through one IDE stream because it controls the communication from RP to EP, right? Okay, device 2 is not trusted by any TDVM because the function 3 not assigned to any TDI VM. Okay, so nobody gives a shit about this one, so they're not trusted. Device 3 is only trusted by TDVM1 because function 4 is assigned to TDVM1. So second IDE stream, only trusted by this bitch. All right. Selective IDE streams used to protect the interconnect between the host CPU and the device, the bridge, and switches uses IDE pass-through mode and are not assumed to be trusted by any TDVM. So there is no faith put in this shit, and it just does the pass-through. That explains it all. So, okay, so the IDE streams, this concept is actually not a per VM concept technically. It is more or less just a means to transport the data to the true PCI. And then there's like some session going on that's probably also like PCIe induced to do this. We're getting this shit. Like a shared SSH encryption tunnel. That's so true. Okay, and here the architecture capability. Based. I don't know, will we have just like fucking writings till the end, or will we have something readable? Ah, okay. I'll go pee. And I'll go get more water. Because it's always good to drink water. I forgot my water. Water. The solution to cause in one single break. Efficient. Efficiency went the way of the PP. Down the drain. True! Okay. Yes. Intel TDX Connect framework is the Intel implementation of TD-ISP, allowing direct assignment through... Okay. True as... Fucking hell. Let's go back to the start. Intel TDX Connect framework is the Intel implementation of TD-ISP, following direct assignment through establishment of trust between TD and TDI hosted by TD-ISP compatible device. The Intel TDX Connect framework goals are to enable the following: establishing a trust relationship between a TD and a TD-ISP device, securing the data path or PCIe interconnect between the host and device. Okay, supporting TD-ISP assignment and removal lifecycle in a trust manner. Okay. Specifically, this framework defines the following ingredient: TEIO capable device and DSM. PCIe integrity and data encryption, CPU hardware access control to protect and isolate TEIO transaction within the host SoC. TDX module extension to support secure TEIO device setup and direct TDI assignment to TD. Okay, are we gaining anything from this? Fuck, what do they mean by DSM? Device Security Manager. Okay, so DSM would be, fuck. What's the idea? DSM. Oh, okay. DSM would be... Okay, I get it. I get it. So on the side of the device, you need to have the capability to answer the question given by the TDX module. Okay. So you start... Oh, that's what we were talking about earlier. That's what we were talking about, like, while it's running, why the fuck does it do SPDM secure, like using the TDX module? That's literally what they're doing here. So they're saying, hey, your TDX module will do some communication on one way and then create the selective stream, the selective IDE stream, right? So then we're able to manage these things. Okay, okay. They're actually explaining it. God damn. It's so good. It's such a good freaking graph. Like, it answers everything. It confirms everything. It's so unhinged, right? So we see here, we have the capability for DMA MMIO. So looking at the memory that way, well, they're written in the other way, right? So DMA is that way and MMIO is that way. We have the start where we do the attestation, so where we link things up. That's done through the TDX module using DSM, so using SPDM secure sessions. And then we can initiate the selective IDE stream, which then transfers the data, which then is the actual, like, real communication method for TDX to forward whatever the fuck the trust domain ask. Goddamn, everything is answered. Red and green color, bad for color if you're like me. Yeah, that's true, but yeah, no, it's kind of fucked. Orange is the same color as grass. Oh, rip. So you're a dog. Yeah, MB, where is my dog? Okay. God damn. Alright, I don't know if we need to read any more of this. I think we can make a pretty good fucking video with that. I want to go into AMD. AMD. Probably going to be the exact same freaking thing. But who gives a shit? I'm in. I'm coked up. Okay, maybe not for that much yapping. Brother, that's going to be a yap and a half. Holy shit, it's it's answering the same question. I don't know how deep I want to go with that, but oh my god. I think in the video, I want to make it clear about how many things are the same. It's unhinged. Like, I've never seen that amount of alignment. Does AMD and Intel are, like, scared as fuck about ARM? What's going on? Oh my god. Do I go into this shit? That would be very funny. But like, what would be funny is if I were able to like match the speed of my voice perfectly and like have the whole explanation be the same. But then like at some very limited point, I switch between the AMD term and the the Intel term. That would be unhinged. Like, just to show how much... Oh wait, that's actually fucking genius! Whoa, whoa, whoa! How about I understand... No. Better than that. I can explain it. Okay, so... Fuck it. Video background. Wow. Video background. Okay. And then we have a fucking shoop. Like this. Whoops. It's crooked a bit, but who gives a shit? Okay, so... We have, like, a split screen. And what I can do is I can do, like, Intel on one side, AMD on the other. And, like, I can build, like, the exact same thing on both sides. And just, like, replace the very limited parts where it is not the same thing. So, I could say, like... Okay, so in this system, fuck, I don't know how I could, like, say this, but, like, just splitting it and just changing the name, and whenever I do the explanation, I could just say, like, on AMD's side, they call it this, in Intel they call it that, and then I can just, like, resume my explanation, because it's so limited the places where the actual verbiage change, right? Like, just look at this shit. Like, what changes? Like, the only difference is, like, trust domain. Sway, come on. We're trying to make a video here. Because like the only difference is the name of the guest, I guess, and like which SoC, and then everything else is almost the same. Maybe Intel has some more. Fuck. That would be an unhinged level of detail. I love it. I love it. Okay, let's go on to that. Fuck the two solution thing and... okay. Video brain. Video brain. We need to go into video brain. Alright. Let me read this, get a feeling for it, and we're gonna edit a bunch of shit. Okay. Let's go to our first feature change of the day, which is the introduction of the PCIe link encryption and device authentication using the new support for AMD. Let's skip this. This is not needed. It's true, but we can put it at the end. So, let's go to our first feature change of the day for the introduction of PCIe link encryption and device authentication. As we've seen in the last kernel vids, most architecture and vendors are trying to make their product more secure on the confidential computing front. AMD SEV, Intel TDX, ARM CCA all have different ways of making sure that malicious hosts couldn't access the data of a guest. PCIe link encryption is the next. We're like jumping to gun. So okay. Maybe cannot. That a malicious not. I was unsure when saying it. I don't know. Does it sound better? AMD SEV, Intel TDX, ARM CCA all have different ways of making sure that a malicious host cannot access the data of a guest. Can't would be the contracted force. I would go with couldn't. Couldn't access. Well, could is like if they wanted to, but it's obvious that they want to because we say malicious host before. So that's why I hesitated why I said it while I said it. I don't know. Let's reread it like 16 times. AMD SEV, Intel TDX, ARM CCA all have different ways of making sure that the malicious host cannot access the data of a guest. Couldn't access. Yeah, couldn't feels a bit off. I'm going to go with that. Like it wouldn't make sense if we inverted it. So ARM CCA all have different ways of making sure that an host couldn't maliciously access. Like that would make sense, but because we already said it is malicious, cannot makes it better. Yeah. So okay, we're good. We're good. Okay. PCIe. As always been outside of the... Oh, this is where the wall analogy would work. I just don't know how to slip it in. PCIe has always been outside of the confidential computing. Wall of these technology. Use an image in the video while you read the original sentence. Like, do you mean this? This part? Like we could... Like use this? Multi-channel information stream. Yeah. Yeah, all of this will need images. And all of these will have their icon. You add a sentence with the trust domain phrasing. Yeah, trust domain trust compute boundary. Oh yeah, I could just like infer this. Okay, so I wouldn't like verbally say it, but I would put the fucking castle in the background. I got it. That would... yeah, I think... Wait a second. I'll make... Nah, no worries. It's going to be funny. Wait a minute. Okay. Okay, let's do the example, okay? Okay. AMD SCV, Intel TDX, ARM CCA, all have different ways of making sure that malicious host cannot access the data of a guest. PCIe has always been outside of the trust compute boundaries of these technologies. And here we have this, and here is... And here is just PCIe just fucking waiting here. Okay. Anyway. I'm memeing hardcore. But that would actually visualize the thing. If I found like a perfect image and just put a fucking PCIe logo. Okay, PCIe has always been outside of the trust compute boundary of their technology. Am I trying to convince you that I am of the? Anyway, PCIe has always been outside of the trust compute boundaries of this technology. Now let's take a moment to understand how communication between PCIe device and secured VM normally happens. In a secured VM, the memory of the VM is encrypted. This removes our ability to ask a PCIe device to read the VM's memory directly through DMA. This forces us to use a software I/O virtualization of the PCIe device. The host will supply the VM with a shared buffer that will then be used with the PCIe device. This is slow, untrusted. In the event that the PCIe device, say a GPU or an accelerator, doesn't have the encryption-decryption capability, it would also force us to leak the information that we sent to the buffer, the information we want to process. All right. Your face. Okay. Okay. Okay, so that introduction is like solid. That's good. Now we could go a little bit into like story time. Fuck. How would I phrase that? Because I don't want to sound... Story explanations are the best. Yeah. And I don't want to go fucking all broady on this shit. And go like, this is historic! And it's like... You could start VM hosting in the cloud. Oh, when I was talking about history, I was more thinking about, like... starting off from all the companies coming together and making the PCIe 7 standard. Because that's kind of historic. Okay. Yeah, the history on the standard. Right, because I can start from like the PCIe 7 standard, like go to what it means, what was achieved, and we could say like that they all came together and agreed, which is true, which is unhinged, and then we could go like in the different implementation. But here I need to make a statement, like to make it interesting, without being fucking cocky about it. Yeah, exactly. Cooperation? What the fuck is this? I hate using now for everything because I do that. You'll see it in the kernel vid. Okay, every time I say so, I say now. It's because I have nothing else to say, and I'm just trying to like shoe in the next fucking statement, and it's retarded. Yeah. Now let's take a look. Bro, collaboration between corporation. All right. Bro. In any other, how do we say circumstance? Circumstances? Circumstance. Okay. In any other circumstance, we would assume that each company, that each vendor would create their own solution to this problem. but they didn't. Bam, bam, bam. PCIe 7.0 released in... It was in June something. Thank you. June 11th. In June 2025. Alright. In June. PCI release in June was the result of unprecedented cooperation between existing confidential computing technologies? Yes. Okay. Nah, I don't think it's that impressive. I mean, it's simple enough. It's like the most bare-bone fucking connector thing. If it was a cable, maybe, but it ain't. Okay, so let's... In any other circumstance, we would assume that each vendor would create their own solution to this problem. But they didn't. PCIe 7.0, released in June 2025, was the result of unprecedented cooperation between Nah, that's too fucking much. Brought a universal solution to this problem. Let's get into it. All right. All right, we're good. In any circumstances, we would assume that each vendor would create their own solutions. Their own solutions to this problem, but they didn't. PCI 7.0, released in June 2025, brought a universal solution to this problem. Let's get into it. All right. The new release brings the concept of the where do I want to start from there? Should I start by the IDE because it's the only thing that fucking matters for us? Or DOE? It's ID that will... I think that the DOE would be false, because DOE is only like a message, while IDE is like the connection stream, right? We didn't read much about IDE. Fuck, it's under what we're looking at. But IDE is the actual thing that we should care about. And technically, IDE probably exists in fucking specification 6, so I would be lying. I would be lying. Oh. Thank you. Oh. Oh! Okay. Okay, yeah. Let's quote that bitch. And this feels... Yeah, we're... Yeah, I know that, Nigma. I don't know how I would separate DOE from IDE. I don't think if it's worth going that deep. That's the issue. Right? Because... like, IDE is fairly simple to understand. We're talking about a beam, a link. DOE, we're talking about requests, packets. Or else I would have to go into CMA SPDM. That's probably what I should go into. Because CMA SPDM is the language by which they're going to communicate to whatever the fuck they need to talk to. And then, like, you add DOE onto it. Well, I have changed. Yes, it's PCI, and PCI is completely different. DOE. I think the DOE is like the less interesting one. CMA, like all that we read is CMA SPDM. And I'm not even sure if I would be able to like convey the understanding of this shit. I don't even know. Do I even understand? Fuck. Okay, can you... Yeah, I think I'll probably need to go into like an alphabet soup for this shit. Like, I'll need to, the new release, bring multiple agreed upon concepts, and then I could list them. Do as you wish, Nigma. I don't think it will do you much good to do that, but do as you wish. Alright, CMA SPDM. So when we're talking about CMA SPDM, we're talking about the language used to, like, I want to dumb this shit down. We're talking about the language used to speak to our device. Okay. The language used to speak to our device. Fuck. I would have to, like, draw shit on screen while this is happening. Over DOE. Am I retarded? Fuck, I don't understand. Okay, so CMA SPDM is the agreed upon language. DOE is the way that we form the packet. And IDE is the fucking beam. I'm repeating that because I'm trying to find if I'm, like, retarded by reading this. I should have started writing this down way more. DOE. A method. Method of fuck, there was a really good, like, explanation for this. Where is my DOE? Boop, 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 boop. Where are you? Shit. CMA IP packet ID. IDE being TCP, I agree with that. DOE being Ethernet packet, I agree with that. CMA SPDM would be like the JSON field that you need to fill to make your request make sense. Or IP. No, you're right, you're right. It's the auth, right? It's the authentication. God damn. Nigma, we're all nerds. How couldn't we couldn't we be nerds? We're currently watching a fucking PCIe documentation that's not even fucking released. Bro, we are the epitome of nerdism, okay? There's layers to it. No, we're at the deepest fucking layers there is. Fucking nerd. Okay. Fuck, let's just define them, okay? Let's just fucking define them. DOE and IDE, okay? IDE. So... akin to TCP, it sets the rule for a tunnel of secured communication between the PCIe device and the TEE / AMD SCV TIO. Okay. See the difference. You're right, maybe we're going too deep into it. Brought a universal solution. Okay, let's back the fuck down. All right. Brought a universal solution to this problem. My brain stops working. Fucking hell. We're so far into it. You cannot not work now! Look at the image! Understand the image! I don't know, maybe we're going too, like, deep into it. Fuck. In any other circumstances, we would assume that each vendor would create their own solution to this problem, but they didn't. PCI 7.0, released in June 2025, brought a universal solution to this problem. The new release... Let's get into it. The new release brings multiple agreed upon concepts. Oh, maybe I need to reverse them. Maybe that's the thing. Okay, let's get into it. The new release brings multiple agreed upon concepts. First, let's start with the IDE, which akin to... And let's even remove this part. To the secured part of the CPU. Okay. Akin to TCP, it sets the rule for a tunnel of secured communications between a PCIe device and the secured part of the CPU. Um, I think I would need to assume this. Maybe I can like bring it to 2 level. Like I could, or an SSH tunnel. Just the word tunnel. Like there's 3 levels of things here. So TCP is like the low to medium knowledge. SSH tunnel is maybe like a little bit higher knowledge, and you just understood tunnel. It's drooling retard. Right? So maybe with that phrasing, it will make it like accessible to everybody, because just hearing tunnel, maybe you think that your data becomes like a moss and you're safe. With SSH, it is better. Yep. Because of tunnel. I don't know. Does anybody like not know SSH tunnel but will know TCP? Yeah, probably. Yeah, probably. If you're not like somebody that messes around with Linux but that knows anything about networks, then yeah, yeah, both of them work. So let's just read this. So the new release brings multiple agreed upon concept. First, the IDE, akin to... Oh, I should spell it out. I should spell it out. Integrity, oh, yeah, we're spelling this shit out. We're spelling it out, boys. We're spelling it out. Integrity and data encryption. Oh, yeah. Oh, we could go into the, like, alphabet soup meme. Soup of acronym. This new release brings multiple agreed upon soup of acronyms. Let's start with Integrity and Data Encryption, IDE. So akin to TCP or an SSH tunnel, it sets the rule for a tunnel of secured communication between the PCIe device and the secured part of the CPU. Goddamn! Based. No, like, of course, normal people don't know what TCP is, but normal people don't watch my videos, so I need to, like, adjust my scope for this. And, like, that's why going with this solution feels very good, because we have TCP, which anybody that has any knowledge of network now understand what the fuck I'm saying. SSH tunnel, anybody that has any knowledge of SSH tunneling, and tunnel, if you're like a drooling retard, will still draw something. Help. Based. Okay. So this sounds fucking great. Okay. Bro, that one's going to be way the fuck too long. CMA. Okay. Component measurement and authentication, secure protocol and data model. Pretty much, yeah. Well, explaining the acronyms is literally like explaining it. Maybe I should split it. So maybe I should like do... And here somewhere, I could like drop this shit in. Yep. Yep. An extension. Of the authentication secure protocol and data model that sets the rules for... It's not communication, it would set the rules... Well, maybe. Set the rules for communication with a PCIe device. Sets the rule for safe communications with a PCIe device. A safer. Fuck. 1F, right? Safer communications with a PCIe device. Okay. We're getting there. We're getting there. We're all sleepy. I was Safish before. DP. No dick pic in this, okay? DOE. The method of packaging the communications sent to the PCIe to and from the PCIe device. And I could like true that, just to give the image to you guys, I would like put the names on the screen, of course, at the right place. Yes, I make kernel videos because I normally like doing them. And if I wouldn't be live streaming it, I don't think I would be liking it as much. Because the last two kernel vids, oh fuck, were they boring to make. I've lost a lot of the passion for this. Because I cannot express it in the way that I want. That's the issue. Good idea. Yes, okay, we agree. Method? Okay, let's just read this shit like in one big freaking swing. And we probably need more. Like, let's get into it. The new release bring multiple agreed upon soup of acronym. We have the Integrity and Data Encryption IDE. It's akin to TCP or an SSH tunnel. It sets the rule for a tunnel of secured communication between the PCIe device and the secured part of the CPU. The Component Measurement and Authentication, SPDM, I should remove this because it makes it unreadable. So the component measurement and authentication, so full name CMA SPDM, is an extension of the secure protocol and data model that sets the rule for safer communication with a PCIe device. And we also have the DOE. We don't spell it out. DOE is Data Object Exchange. DOE. And we also have the Data Object Exchange, DOE, the method of packaging the communication sent to and from a PCIe device. Oh, the counter would be a good one. Oh. 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 I like this. I like this a lot. Yeah. Oh, yeah. Yes. I need to put an increment here too. No! Bro, it would be unhinged. The new release brings multiple agreed-upon soup of acronyms. Integrity and data encryption, IDE, ping, akin to TCP, ping, or an SSH tunnel, ping. It sets the rule for a tunnel of secured communication between the PCIe ping device and the secured part of the CPU, ping. Bro. Oh, that would be so dumb. Fucking hit markers for my acronyms. Oh, we need that, we need that. Alright, so with that... That would... Like, the smoke detector beep... That could be misconstrued as slightly racist. And I ain't going that route, okay? I don't know. I don't want some fucking racist comments in my reply. Nigma, it's okay if you don't understand. Nigma, if you don't know a thing, it's okay. But the beep from a smoke detector is a very, like, whenever you talk about that on the internet, you will attract racist people, okay? It is important that you don't talk about that, okay? So stay away from that beep. Because all that people will understand from my video is black people. That's all that the people that on the fucking Instagram reels will get from this. Alright. But nice idea, MB. Nice idea. Do a search. Yep, do a search, Nigma. You know what? I'll do it for you. Okay? So let's do smoke detector beep. Okay? Do a smoke detector beep. Okay? Do we do a smoke detector beep? Come on, what the fuck is this? You're telling me that I'm not going to get my fucking racist reply on Bing? Okay. Okay, the meme is that... Fucking hell. I need to fucking outline that. Okay? Is that black people... Okay, fucking Bing. Fucking Bing. Thank you, Bing. Thank you, Bing. Oh, thank you, Bing. Thank you. Okay. Smoke detector be black. The meme about smoke detector beeping has been a topic of discussion for years, but it gained a new twist in the early 2020s. The sound of a smoke alarm chirping has been associated with black people due to the stereotype that many in these communities do not change the batteries in their smoke detectors. The stereotype has been fueled by memes and social media posts that highlight the behavior of black people in relation to the smoke alarm, okay? So, the smoke detector beep, okay? It has also been called like the hood cricket, okay? There's a lot of memes, okay? So, we can make the hood cricket meme, okay? So, like, beep, okay? Like, we've got the fucking memes. Okay? We've got it. And there's all of those fucking racist thing. Right? So that's the thing. Enough. Enough. Okay. So whenever I'm saying that you are subtly saying something fucking racist, I'm not saying it to be an asshole. I'm saying it so that you know. That's all. Okay? Oh, man. Alright. It's okay. Be racist. Just know that you can encounter racists, right? I'm not saying that you are. I'm saying that you can bring these people upon you. And that's a bad thing. Okay, you're going too far now. Okay, you're going too far. All right, I'll go P40 like 1500 time, and we'll have to think about how we want to explain this shit. I think I'll go right into examples, or else it will be hard to explain. And also, you cannot say, I'm just so lost, man. How do people make these things? Whenever you were making fucking arguments that, like, they need to be assimilated, and they didn't have enough time to adjust to the new culture, okay? Okay. Anyway, I'm not getting trapped, okay? So we have integrity and data. So we have IDE, we have CMA SPDM that explain, we have DOE. So all of those are explained. So now with that, we would be able to start constructing the idea of like a VM. So right now we could probably like make the example in a company agnostic way, right? So keep in mind, we've already explained like how this is a problem. And fucking hell. Okay. And now we could explain how this is fixed, right? So okay. Let's see in practice how these concepts are implemented. Take a VM secured by secured by a trusted execution environment. And there we could display on the screen Intel TDX and AMD SEV. All right. All right. Pick a VM secured by trusted by a trusted execution environment. Intel TDX, AMD SVM, SEV. VM. Take a VM. Okay. My brain. Fuck. I've thought too much for today, I guess. Okay. Nice. VM. Secured by trusted execution environment. Okay, so I could say a TEE. The TEE would, upon detecting compatible hardware. Fuck, maybe we need to explain TDISP. Oh no, that's Fuck it. No, that's not it. Okay. The TEE would, upon detecting compatible hardware, make it available to the VMs. To the VM. By default, no permission or access is given to the PCIe device. I should make it more categorical. No permission or access is given to the PCIe device without the VM's approval. The VM can then request to the TEE to get access to a function of the PCIe device. The TEE will then proceed to create a IDE connection with the PCIe device, encrypting its communication and allowing the VM access to the function. Subsequent transfers would be done using the CMA SPDM standard true DOE packets. True, the DOE format. God damn. I'm not going to click on a link if I haven't clicked it now. Hello, Rust. Okay, let's read this shit. Okay, let's get into it. The new release brings multiple agreed upon soup of acronym. Integrity and Data Encryption IDE. Akin to TCP or an SSH tunnel, it sets the rule for a tunnel of secured communication between the PCIe device and the secured part of the CPU. Component Measurement and Authentication, CMA-SPDM, an extension of the Secured Protocol and Data Model that sets the rule for safer communication with a PCIe device. Data Object Exchange DOE, the method of packaging the communication sent to and from the PCIe device. Let's see in practice how these concepts are implemented. Take a VM secured by trusted secured by a trusted execution environment, TEE. So there we would have a display for Intel TDX or AMD SEV. The TEE would, upon detecting compatible hardware, make it available to the VM. No permission or access is given to the PCIe device without the VM's approval. The VM can request to the TEE to get access to a function of the PCIe device. The TEE will then proceed to create an IDE connection with the PCIe device, encrypting its communication and allowing the VM access to the function. Subsequent transfers would be done using the CMA SPDM standard through the DOE format. And then we could, like, clean this shit off. We need to dumb it down. Now we've explained the thing. We need to explain how it solves anything. Right? So this solves two fundamental issues with PCIe communications from VMs. One. First, the communications to the PCIe PCIe is now hidden and encrypted, is now hidden from the host the communication is encrypted. And 3, I had another thing I wanted to say. Yapping too hard. Oh, performance. We do not require to transfer the data to a buffer before sending it to the PCIe device. That's clean. Yep. This is not the only okay. PCIe 7.0 also brings solutions would allow with the VM's authorization. Fucking hell, that's the word. With the VM authorization, DMA operations 1P operations directly to the VM's memory increasing performance. Fundamental. Okay, we do not require to transfer the data to a buffer before, and then you would transfer it, you would say, before, instead, sending between device. Between okay, let's read this shit, I guess. Okay, this solves 3 fundamental issues with PCIe communication from VMs. Yes. We should say from confidentials. Confidential. Okay, this solves 3 fundamental issues with PCIe communications from confidential VMs. The communication to the PCIe is now hidden from the host, the communication is encrypted, and we do not require to transfer the data to a buffer before sending between the PCIe device and the VM. PCIe 7, PCIe 7.0 also allows, with the VM authorization, DMA operations directly to the VM's memory, increasing performance. Change from with. Fuck, where is that? Oh, with. Okay, I get it. This solves 3 fundamental issues with PCIe communication with confidential VMs. Oh, that's so much good. Good catch, good catch. Alright. We're building a fucking text, bro. Not just from VMs, but also to. Okay, I understand what you mean. Alright. Like this is a memory. This is real large language model. True! Okay. What other, like, fun fact do we want to drop in this shit? Oh, maybe I could talk about this. But also with the VMware. Yeah, it would be instant chaos. Although, for some research, it would be insane. I would absolutely do it. We should have like a Google Doc. Would be good meme, good meme. Would be pretty cool. PCIe 7.0 also allows, with a VM's authorization, DMA operation directly to the VM memory. Now we could I would help by inserting emojis based. Now we should probably like talk a little bit about the fact that a device could be divided. Maybe that's interesting. Base. All right. The standard also outline how a PCIe device should be divided. What? Brain? Oh, divided. Okay, divided. Should be divided in order to have multiple VMs accessing different functions of the same device at the same time. And we should probably revert to the kernel at this point, because we've yapped about the fucking PCIe 7 thing for hours. All right. Now, back to the kernel. The implementation of this standard has begun. Has started. True, I could go deeper in the function thing. The standard also outlines how a PCIe device should be divided in order to have multiple VMs accessing different functions of the same device at the same time. For example, a PCIe accelerator that is compliant with this new standard could have multiple processing unit, each encrypted with their own key. and unable to access each other's memory. Alright, let's reread that. The standard also outlines how a PCIe device should be divided in order to have multiple VM accessing different function of the same device at the same time. For example, a PCIe accelerator that is compliant with this new standard could have multiple processing units, each encrypted with their own key and unable to access each other's memory. I feel like I'm not explaining anything, but I'm just restating a thing. It's kind of triggering. Like, I don't know how much detail I want to go on this. I think I'll cut a couple of things. This standard also outlines how a PCI device should be divided in functions. In functions, and then we could do like in functions accessible using TDISP. That would be the way to go. The standard also outlines how a PCI device should be divided in functions. In accessible by, and it would be T-device interface, TDI. T-device interface, TDI. Each TDI would have their own that's redundant. I have a like quasi explanation of DMA at the start. No, you're good. HDDI. Each TDI would be separated. Oh, that's very fucking true. Okay, what I could do is make an example right away, right? So let's think of a four port network card. Each port is linked to a TDI. Each TDI VM may grant, you're right. Each port is a function and is linked to a TDI. Okay, let's think of a 4-port network card. Each port is a function and is linked to a TDI. A VM may grant the TDI DMA access to its VM memory. Or send packets directly through the card. PCI these communications and are all encrypted under the IDE connection away from the host and would it be encrypted using? Yes, it would be encrypted using the VM key. Oh, no, that's not something that I would need to say. What I would say, okay, these communications are all encrypted under the IDE connection away from the host and the TEE. And the TEE along with the TDI ensures that one VM cannot interfere with another. I don't know if getting to that level is useful. I think that just showing images will be good enough for this. Let's just like read. Let's read this shit again. Right. Okay. I don't know how far back I want to read this. Let's make it like it's the video, okay? Let's see in practice how these concepts are implemented. Take a VM secured by Trusted Execution Environment, TEE. The TEE would, upon detecting compatible hardware, make it available to the VM. No permission or access is given to the PCIe device without the VM's approval. The VM can request to the TEE to get access to a function of the PCIe device. The TEE will then proceed to create an IDE connection with the PCIe device, encrypting its communication and allowing the VM access to the function. Subsequent transfers would be done using the CMA SPDM standard through the DOE format. This solves three fundamental issues with PCIe communication with confidential VMs. 1. The communications to the PCIe is now hidden from the host. 2. Communication is encrypted. And 3. We do not require to transfer data to a buffer before sending it between the PCIe device and the VM. PCIe 7.0 also allows, with the VM authorization, DMA operation directly to the VM's memory, increasing performance. The standard also outlines how a PCIe device should be divided in functions accessible by by a TEE device interface, a TDI. Let's think of a 4-port network card. Each port is a function and is linked to a TDI. A VM may grant a TDI DMA access to its VM memory. To its memory. Or, a VM may grant the TDI DMA access to its memory or send packet directly through the card. These communications are all encrypted under the IDE communication away from the host, and the TEE along with the TDI ensures that one VM cannot interfere with another. Am I like this? Yeah. Hi. All right. No. IPC has nothing to do with this. Nothing. Alright. So let's just think about what we did, right? We explained a few quote-unquote new, I'm sure they were there for PCIe 6, but they were not explicitly like defined. And DMA can be used outside of IPC. Okay. So, okay, we define our thing. Well, before that, we define the problem. We say that there was a solution. We go through some definitions. We explain the inner working of the thing. We say how it fixes 3 main problems. Then we go into how things are divided by the interface. Now it's probably good to like rotate back to the kernel, because right now we're PCIe like full fucking tutorial, okay? we're leaking some fucking secrets over here. Now back to the kernel. Unless there's something like interesting that I'm skipping, but I don't think so. Yes, okay. The DMA is the physical part, and the IPC is the software side. Yes, that's the thing. Because it is implemented by the... Because it is implemented by the TEE, it is not IPC. Alright. Now back to the kernel. The implementation of this standard has started. I would like to mention the maturity map, but I don't know when. I'm so lazy right now. All right, let's be generic with what the fuck we're talking about. I would release it in the video. I don't give a shit. Unless he does it like this Saturday? This Sunday? I always mix them up. Sunday, sorry. This Sunday? If he does, I'll be triggered. But if he does like next week for the RC8, he can go fuck himself, okay? I'll release it. And I'll add a little note at the end saying, Storm, it wasn't since its release, it was cut out, lol. Have fun with the explanation, bitch. Okay. Implementation of this standard has started, but it is far from finished. The internal wiring for the fucking hell wiring to my understanding is just like the very basic like enabling of the feature, like just pinging the feature is what we have. Oh, well, no, I'm lying. The framework. Enigma. Ah, Enigma, I love you. You're saying things that shows that you didn't understand jack shit, but it's okay. I love you. You get that everything that we've talked about only increases performance for a feature that already exists. That's all. All right. I'm talking about the kernel too. Okay, let me explain. AMD SEV already exists, okay? It already is there. Intel TDX already is there. Right now, we are slow, okay? Whenever we do communications through PCIe, because of this. We are slow and unsecured. So right now, the addition of this doesn't bring any more slowness. It actually speeds things up because we have less step to go through to make this happen. So it is an upgrade, right? It is a pure upgrade. So when you talk about like Rogue Driver or performance and all of this, like we're not there. It's something that is like not an issue. It's not in the scope of any of this. All right. So right now we could speak about the core. Oh, fuck it. All right. We could say the internal wiring for... Okay, the internal wiring for handling the IDE connection. Yes, thank you, MB. Like, there's no syscall. There's no none of that because it's the fucking silicon doing the thing. And all that we do is we say, there's a GPU. There, I see it, GPU. And the magic starts. Internal wiring for handling the IDE connection. And the framework. Fuck. The framework for initiating secured. Okay, the internal wiring. Okay. The code. The code. Handling the ID connection and the framework for initiating secured connection. was added to the kernel, for this release, only the AMD SEV TIO was the name. Trusted IO. Boop 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 boo. Implementation. But the Intel PDX Connect and ARM CCA currently wait safely. How could I say that it's waiting in the fucking, like, 3. Currently waiting in its own 3. Okay. Classic Nigma. It was my phrasing. And BB like, no. I just like... Oh, that's so good. I love it. Or my phrasing. Shut the fuck up. It's so fucking violent. Yes, it's possible, Nigma. Okay. If you have something that is done by software now being done by optimized hardware, what happened, right? What happened when we implement inside of hashing code, like something that is able to do SHA-256 inside of the fucking CPU, like hardware? What happened? It becomes faster because we remove everything. Right, we remove all of the overhead of the software solution, all of the fucking pathways, magical things that we were trying to do. You just shove it into the silicon, and you're good to go. Nigma. Of course, everything has fucking overhead. The thing is that if it's handled by something that is asynchronously running, like it's not running at the same place, I'm talking about the kernel too. You get that these optimization for like SHA-256 and shit. They exist in the kernel. It shows. Okay. Now back to the kernel. The implementation of this standard has started, but it is far from finished. The code handling the IDE connection and the framework for initiating a secured connection was added to the kernel. For this release, only the AMD SEV-TIO, Trusted IO, implementation has been added, but Intel TDX Connect and ARM CCA are currently waiting in their Oh, I should probably name the subsystem. The name given to from this standard, a new subsystem is born. Okay, now back to the kernel. From this standard, a new subsystem is born. The PCI Trusted Execution Environment Security Manager, TSM. The code handling the IDE connection and the framework for initiating secure connection was added to the kernel. For this release, only the AMD SEV-TIO implementation has been added to the kernel, but Intel TDX Connect and ARM CCA are currently waiting in the TSM3. In the new TSM3. The implementation of this standard has started, but it is far from finished. I don't even know if I want to say that phrase. The maintainers, the devs. The devs have given us a maturity map. We still have a long way to go, but I'll keep you updated. And all of this bullshit can go. Oh, what a great freaking link. All right, let's read a bit. Maybe not depend on the flow. It's move my better for the flow. There is still work to do. Yes. It's just the... It's just the fur. Oh, are you, like, rephrasing this? Daughter's going great. She's having fun. Oh yeah, I like streaming. When I was younger, I used to stream 12 hours a day in the summer. So, broski, I'm in. Yes, bright. Don't change it. You found the right one. Alright. So I don't know, we could reread this just to make sure that it flows. Of course, there's a bunch of image that we would blast on screen. But this is a heck of a fucking introduction. Holy shit. Oh, maybe I can make here. Maybe I can say TSM. Let's keep it vague, maybe. So like, let's phrase it like I would in a video, right? Let's phrase it. So let's get to the first featured change of the day, which is the introduction of the TSM. Now, before we get into that, as we've seen in the last kernel videos, more architecture and vendors are trying to make their product more secure on the confidential computing front. We have AMD SEV, Intel TDX, ARM CCA, all have different ways of making sure that malicious hosts cannot access the data of a guest. PCIe has always been outside of the trust compute boundary of these technologies. Technologies. Multiple, right? Of these technologies. I don't think that it's worth it for digging. Maybe, but I feel like 99% of the shit is the same. Now let's take a moment to understand how communication between PCIe device and secured VMs normally happen. In a secured VM, the memory of the VM is encrypted. This removes our ability to ask a PCIe device to read the VM's memory directly through DMA. This forces us to use a software I/O virtualization of the PCIe device. The host will supply the VM with a shared buffer that will then be used with the PCIe device. This is slow and untrusted. In the event that the PCIe device, say a GPU or an accelerator, doesn't have encryption/decryption capabilities, it would also force us to leak the information that we send to the buffer, the information that we want to process. In any other circumstances, we would assume that each vendor... This doesn't roll off. In any other circumstances... maybe it does. In any other circumstances, we would assume that each vendor would create their own solution for this problem. But they didn't. But they did not. PCIe 7.0 released in June 2025 brought a universal solution to this problem. Let's get into it. The new release brings multiple agreed upon soup of acronym. Ding! Integration and data encryption. IDE, akin to TCP or an SSH tunnel, it sets the rule for a tunnel of secured communication between the PCIe device and the secured part of the CPU. Let's just be sure that I'm not... yes, plural. Okay. Component measurement and authentication, CMA SPDM. An extension of... we should, like, phrase it a bit more. So, component measurement and authentication, CMA SPDM, is an extension of the secure protocol and data model that sets the rule for safer communication with a PCIe device, and the Data Object Exchange, DOE, the method of packaging the communication sent to and from the PCIe device. Let's see in practice how these concepts are implemented. Take a VM secured by a Trusted Execution Environment, TEE. The TEE would, upon detecting compatible hardware, make it available to the VM. No permission or access is given to the PCIe device without the VM's approval. The VM can then request to the TEE to get access to a function of the PCIe device. The TEE will then proceed to create an IDE connection with the PCIe device, encrypting its communication and allowing the VM access to the function. Subsequent transfers would be done using the CMA SPDM standard through the DOE format. This solves three fundamental issues with PCIe communication There's two with, and it kind of fucks me there. The VM can then, should be, the VM can then. Oh, really? Then. Okay. Like, there's two with there. It kind of fucks me, I don't know. Maybe it's just my brain right now. This solves three fundamental issues with PCIe communication. Because from would be retarded, with two withs in a row. Maybe I can change the first with. Happening when using. On this side, it doesn't make sense to me. This solves three fundamental issues when using PCIe communication with confidential VMs. This solves three fundamental issues with PCIe communications when using confidential VMs. Doesn't that, like, roll better? Like, I don't know. This solves three fundamental issues when using PCIe communication. PCIe communication is the medium. So, when using... I prefer this one. The communication to the PC... Let's reread from the start. It fucks up, or if I don't do this. This solves three fundamental issues with PCIe communication when using confidential VMs. First, the communication to the PCIe is now hidden from the host. Second, I would phrase it a little bit differently. First, the communication to the PCIe is now hidden. To be honest, Nigma, neither, because I don't have that much time to game. Or I'm not interested in making game anymore, too. I think that the optimization that could happen with voxel-like game is, like, very interesting. But that's me, like, mental masturbating myself. Right, that's the only reason why I would choose the voxel, is because I would like to understand the optimization that can come with it. All right, the communication to the PCIe. To the PCIe is now hidden from the host. The communication is encrypted. We do not require to transfer data to a buffer before sending between the PCIe device to the VM. That phrase is garbage. We've like modified it too much. We do not require a buffer. We do not require a buffer for communications. We do not require a buffer for communications between the PCIe device and the VM. All right, that sounds a bit better, right? Because we have communications like come in 3 times, so, and the fundamental issue it's with PCIe communication, so it fits. So let's reread this fast as we would. The communication to the PCIe is now hidden from the host. The communication is now encrypted, and we would not require a buffer for communications between the PCIe device and the VM. PCIe 7.0 also allows, with the VM's authorization, DMA operations directly to the VM's memory, increasing performance. The standard also outlines how a PCIe device should be divided in functions accessible by a TEE device interface. Let's think of a 4-port network card. Do I explain anywhere what the fuck a TEE is? Like where I say that it's a part of a CPU? I should probably explain this. Do it. I can't wait to play it. Like, I don't want to play it, bitch. Oh no. Okay. Okay, let's just fix this. Take a VM secured by a trusted TEE. And maybe here we can do like an explanation. The secured part of the CPU that manages the VMs Let's see in practice how these concepts are implemented. Let's take a VM secured by a trusted execution environment, a TEE. This is the secured part of a CPU that manages VM, so Intel TDX or... Oh, that would be good. That would be good! Okay, let's put this there. That manages a VM, so Intel TDX or AMD SEV. The TEE would, upon detecting compatible hardware, make it available to the VM. I don't know how I'll switch with that, but that's just, like, vibes. Okay. This is a secured part of the CPU that manages the VM. Alright, good. Okay. The standard also outlines how a PCIe device should be divided in functions accessible by a TEE device interface, a TDI. Let's think of a 4-port network card. Each port is a function and is linked to a TDI. A VM may grant the TDI DMA access. A VM may grant the TDI DMA access to its memory or send packets directly through the card. These communications are all encrypted under the IDE connection away from the host, and the TEE, along with the TDI, ensures that one VM cannot interfere with another. we've explained the fuck ton. That sounds great. Now, back to the kernel. From this standard, a new subsystem is born. The PCI Trusted Execution Environment System Manager. Security Manager. I'm too sad. I'm too sleepy. I cannot even think. Holy shit. The PCI Trusted Execution Environment Security Manager. Fuck me. Oh my god. Okay. The code handling the IDE connection and the framework for initiating secured connection was added to the kernel. For this release, only the AMD SCVTIO Trusted IO implementation has been added. But should I add a comma here, or else I'll read it like shit? The code handling the IDE connection and the framework for initiating secured connection was added to the kernel. For this release, only the AMD SCVTIO Trusted IO implementation was added. There's too much added here, but okay. The code handling the IDE connection and could be included. Oh, the second one, I think. Was included. I think that... the other way around, I didn't like how it sounded in my head. But that's a great idea. Okay, let's reread this. Now, back to the kernel. From this standard, a new subsystem is born, the PCI Trusted Execution Environment Security Manager. The code handling the IDE connection and the framework for initiating secured connection was added to the kernel. For this release, only the AMD SCVTIO Trusted IO implementation was included, but Intel TDX Connect and ARM CCA are currently waiting in the new TSM tree. Now the devs have given us a maturity map. We still have a long way to go. I'll keep you updated. That's good. Yes, they only put PCI for some reason. They want to fuck you over. Well, technically PCI, the E is little e. It's not capital E, right? Because it's made by PCI SGI? SIG, I mean. So that would be logical. Hey, that's a fucking banger. Please don't say that. Please don't say that, MB. Don't fuck him over more than he already is, okay? We both know that it's Express. For the love of God. If it's not Express, I'll kill myself, okay? We both know. I was that close from ending it. God damn, that was an interesting read. You were talking about like the difference between the two. But I mean, I feel like first of all, AMD will always use like 99% of what the standard is. If if AMD is good at one thing, is using standards. Okay, they love it. But it seems that even then, everything looks so much the same. TVM. Where do you see TVM? TVM. Oh. Host with TVM. So by that they would mean the VM itself. Like trusted VM. Right? TVM. Don't tell me that it only exists here. Trusted virtual machines. So they could just have said VM. Yeah, this AMD are good to follow fucking standards. It's so good. Like, and look at this. Look at this. Such a good explanation. God damn. Okay, let's just put some notes for the people that have a soul. Oh man, where did I get this now? Quick moment, I'll have to search this again. Just want to put some note down. No! Alright. Oh yeah, oh yeah. Okay, we got it. We got it. PDF. Broski. Can I have... Bro, why are you doing this to me? Boop. Oh, fuck this. Is that the right thing? It is. Okay. Let's copy this. Okay. Sources. TDX. Connect. So that's one. AMD. SCV. EIO. So that's another one. That's already written. Batch. What happened? All right, TDX Connect. SCVTIO patch. We have the maturity map here. I cannot really pin this because I'm going to get my ass kicked. I'll probably need to like shut down remove the stream from the internet after this. I like how you preempted Nigma. I love it. Nowhere do I talk about device verification. And I feel like that's a part that's pretty freaking important. It feels like AMD are not talking about it at all. Well, they're talking about it, but it's like, we're going to do something. Something will happen, guys. I swear. But it's really impressive, right? Because from the start I was like, no fucking way this is going to be cross-platform. But right now, like, besides the confirmation of whatever the fuck you're looking at, it is. Like, let's assume that they figure out... Let's assume that the communication to the IOMMU are universal. Which they're not, but I'm sure this can be adjusted. This shit is cross-platform. This is unhinged. Oh yeah, I'm not saying that it's not going to... Like, that it's going to be the same in that way. What I'm like thinking about here, my stress was that we had to have different silicon, right? So if you have an accelerator or a GPU that you put inside of a TD machine, it would have to be a TD silicon, right? TDX, I mean, TDX silicon, or same thing with AMD, right? So that was like a little bit scary. But for now, like, if they figure out the confirming that the thing we're looking at is really the thing, we're there, right? Yeah, that's insane, right? Because ARM has PCIe, right? ARM is able to, like, have PCIe. ARM will be compatible with this shit. Well, like, you say, I still don't know how they would validate it. Like, maybe I'm not getting deep enough, but I feel like if you were able to, like, have a chip do a self-test, and from the values that it gets from that self-test, be able to, like, multiply it with a specific key, like, that would make sense, right? If you're able to test each part of the thing, if you're able to test, like, if it's the same memory chip, if the model of the memory chip has been changed, if this is that, right? If you're able to, like, tweak all of that and pass it through a certificate. Sounds good to me. Like, let's keep in mind that in that world, these constructor would have to share a root certificate or have, like, a couple of root certificates that they could issue. Or maybe we're all retarded. And in reality, they could each have their own root certificate, like their own certificate that they use for every individual device. So you could use that to verify that the device truly is what it is. It doesn't matter that TDX would detect it, because you could make that check, right? But then we are gatekeeping hardware. No. That's the thing. We're not gate. It's the other way around, right? Why would TDX, or like I'm using TDX as a thing? Yes, you could issue your own certificate, right? So let's say that you make your own hardware. You issue your own certificate. You say to everybody, hey, buddy, this is how you test, right? So the test. So it doesn't mean anything. Well, yes and no, right? If you buy hardware from NVIDIA, you're going to test against the NVIDIA certificate. That's already how we do things, right? Everybody can do an HTTPS certificate. The only reason why it's valid is because we can trust it towards the higher authority source, right? But what about the higher authority source is just a vendor? I'm not saying, okay, at the end of the day, I am a rogue hardware provider. I will provide my own certificate. Yes. I meant that you could read, for example, a GPU flash, and a program could their own flash with that data. Well, that's already something that is protected against, right? That's already something that has been resolved. There is a way to write shit that is not, that cannot be read, or that is like, okay, first of all, a public key exists, right? Do we agree on this? Right? You don't have to have the private key of the website for it to work. So you could have a symmetric certificate. We agree. Good. We agree. Asymmetric certificate, so certificate that can, like, one side encrypt, one side decrypt, exists. Now, Intel and AMD have already found a way to put into their silicon a signature that allows them to know if a chip is a real TDX chip or if it's something else. They are already able to do that. So, like, I understand that maybe the technology for fucking around with, like, the silicon of a CPU is a little bit more complicated, but if it could truly just be resolved by fucking, like, scratching the silicon over and over again and looking and doing that multiple times until you have the key, it would be worth nothing. So they have a way of doing this. Like, this is not... This seems pretty trivial. Maybe it would be... Maybe it could be badly implemented. Right? I'm not only talking to you, Enigma. Maybe it could be badly implemented. But if we assume that NVIDIA and all the others are doing their job, they should be able to self-check. But I feel that, oh man, MB, if you get like some detail about how this works, that would be something cool. I'll try to see on my side, but I don't know how much I'll sleep. Yep, if you find anything, let me know. I'm not sure how that would do that, seeing how making the hardware level secure is very, very hard. Okay. Okay, let's think about this. Could we have a system where we have a private key that, like, where the private key and the public key is inverted? Right, so one, so instead of, like, one is doing decryption, the other is doing encryption and decryption. We have, like, one is doing, like, only one is able to do encryption, and the other one is only able to do decryption. Like, if you had a key like that, then you would have fixed it all, right? Because you make the decryption key public, the encryption key private, and then you're able to check the stats of your self-test. But that's just like me, like fucking winging it all in 5.5 seconds. Like, I don't know. Well, no, a USB device could not hack a whole system in mere millisecond upon connecting it. Not without you making a setup or knowing that there is a flaw in your system. That doesn't exist, right? You get that if you plug a USB key on a fucking Google server, it won't do shit. If you... first of all, they don't have USB, but if they did. But if they have found a solution, that's great. To be honest, you and me don't have a real say here. Well, I have a say about something that already exists, right? I cannot say how it's implemented, but I can point to real thing that exists, right? Oh man, that would be so cool. Not necessarily act, but certainly compromise. Well, it depends what you mean by compromise, right? At Google, if you did that, it would be a compromise because there is a possibility that, like, you would blow up a USB port and you would shut down a server. Or maybe that you, like, have a 0-day giga fucking FBI that fucks up everything. So it is considered a compromise because there is a possibility of something that is unknown by everyone in the world but like one person, and that it happens to them because the stakes are that high. But like it is not a realistic standard to pin anything against. Above the meat, better. I'm sure they don't laugh at us. I'm sure they would appreciate us trying to understand. Like, the IO capable device is defined specification. Okay. Okay, so they seem to be saying exactly that. Wait. Okay, that's exactly what I fucking said. Holy shit. Okay. So, let's just read this. TEEIO capable device also implement measurement register, which holds the cryptographic hash value of the firmware/software or configuration data of the device. In response to a request from the TD, so the trust domain, so the VM, right? The device provides the measurement signed with the private key. So it signs against private key. This allows the TD to establish the identity and measurement of the firmware software configuration of the device. So you get the root certificate. Okay, so they literally are doing the reverse thing. Holy fucking shit. Am I retarded? Yes, a lot of parts of this is old standard. But PCIe 7.0 is new. So TLDR, they have a certificate that can encrypt shit and a certificate that can decrypt. You have the one that decrypts. They have the one that encrypts. They encrypt with the firmware, software information, and everything you need to confirm that the shit is supposed to work. And on your side, you're able to confirm. Holy fucking shit. Well, encrypt and decrypt is probably dumb to say, but they sign it. That's the point. I should probably, like, talk about that in the thing. That's so cool. So we could do like, now. Let's use now again. Oh no. The skeptics among you might say. No, the key is given by the vendor, right? That's the idea. A trusted root certificate authority generates a root certificate provisioned to the TD, right? So the idea is you give a root certificate to the TD. The woo for this truly doesn't fucking matter. Yes! Still not seeing this as secure. Okay, no. You're wrong. I need to draw it out, okay? It is secure. In every way, okay? Think of a GPU. I'm saying you're wrong, but it would be better to say, I'm not sure you understand, okay? Think of a GPU, okay? An accelerator, okay? And the accelerator has a couple of cores. It has some memory. And it has a firmware on a specific chip, right? So somewhere in there, it has the ability to sign a certificate. Of course, that ability to sign is like secret fucking thing that you cannot like do yourself unless you're the company, right? Unless you're the maker of this GPU, right? Of this thing. So what the chip does whenever you request its information is it will get like the information here about this chip, some information here, information there, Permission there, what chip we have, what's the fucking firmware, what's the time, right? What's the time that we have? And then it returns that. So by conjugating all of these things, right? If you have the time, if you, because you need something that moves, right? If you have all of these values all over the card, then you're able to confirm, is this, first of all, is the signature valid? And second of all, is the other information valid? And if these two things are valid, this means that you have a true thing that wasn't fucked around with. If they manage to fucked around with, and it wouldn't like trigger something, that means that the person that made the fucking accelerator is a retard, which we never assume. Well, come on. I mean, we implicitly we implicitly trust Intel, right? So why couldn't we implicitly trust NVIDIA? Because here what you're saying is that NVIDIA would have lied about their software or about their GPUs to everyone, because your source of truth, you're not searching it on a forum, you're searching it on AMD's website, on NVIDIA's website, right? I can make fake AMD GPU. Yes, but the fake AMD GPU doesn't have these checks, right? The fake AMD GPU is a true AMD GPU with a new name on it. Right? It's just a firmware change. With that check, with these check, it would fail them. Nothing is validating the keys in the hardware to a central repository of... Well, yes, it is. Whenever you have a signature on a thing, you can have another certificate check that signature without internet. Do you agree on that? This is my understanding. You can have a program just meant to check a signature. Like MB. Well, yes, okay, I agree with you, MB, I agree. But that's because none of the hardware has the ability to verify the signature, right? You get that the GPU that you're talking about is a GPU that is not made for this. So if it was a GPU that was made for this, and that was correctly made, it would have by default, when I say correctly made, let's just be precise. When I say correctly made, I mean, like, let's say that the name of the GPU is the T1000, okay? So every T1000 on the planet would have this signature. They would all be, made the same. So when I say not made correctly, I mean that if the T1000 is not able to self-check and to sign things correctly, that means that NVIDIA, if it was NVIDIA doing it, would be retards. And that's not something that we should assume, right? If we assume that Intel is retarded and that their signature is worthless, well then, let's not have hardware, right? Why do we even have fucking hardware? But here, what they're stating they should do is you get the self-test from the PCIe device, you have the program that's able to look upon it, see if it's legit, and you should be yourself able to like see that the signature is legit and see all of the other information from that PCIe device. So you cannot just like If you clone everything to a T, how could it detect something different? Okay, let's say that you clone everything perfectly. Okay? Just clone everything perfectly. Then, spoiler alert, you've got a second valid card. But whenever you break things, whenever you try to make it a bad card, whenever you put like spy agent in it, if the design is made in a good way, it would be able to detect that. That's on the hardware design side of things, right? It's outside of the scope. The technology here is we're supposed to be able to get a signed object back from it. Where's the public repository store all of those keys? We need a public key to validate. Yes, this is what they're saying here, right? A trusted root certificate authority generates a root certificate provision to the TD. So what they're saying here is whenever you will buy that future hardware that is enabled for this, you will have access to a key, right? They're not saying that the key is in TDX. And they're not saying that the key is magic. This is something that will be given. It will be in the download section of the fucking thing. Well, I say in the download section. Those things are normally like kept to only the people that buy the thing, right? So you'll. Well, no, sorry. It would be public. I'm a retard. That part would be public. Yes. Okay. Nigma, I'll phrase it in a way, and I think it will fit. The first time I said it wrong. Signature is the right way to see it. Yes, Nigma, I know that could work, but there is an issue with that, is that could also be faked. So the way that you fix that is that you make it a stamp, right? You sign it. When you stamp it, when you sign it, what you're saying is the data that I'm giving you is valid data that has been checked, that is like being output by the system. So when you sign it, you're able to check that the thing is actually like working, that it's valid, and then you can check the values within it to see if it passes the internal check. So let's take the AMD Rogue card. Let's go with the AMD Rogue card, right? So the thing that it would do is it would first, because it has the AMD firmware, it would return, hey bucko, we've got like this, I've got the AMD key, okay, for this specific thing. Let's say that somehow they have the chip for it, right? So we have the AMD key for this. So you would be like, oh, key is valid. That's good. And then you would check the other values. What the fuck? The memory is not the same. This thing is not the same. The values that are encoded into these chips are not supposed to be there. And then you can, whoa, what the fuck? It's not valid, right? It's the two together. So the key, if the key is fake, the rest, like, if the two things are true, if the two things work, it means that you literally have a full GPU. It can, or a full, like, card. It cannot be anything else. My Rogue card won't pass the AMD card check because I don't have AMD's private key. Yes, but let's say that you, even if they would like put the chip with the AMD private key on it, the AMD check should still detect it as failing because the values are not the same as the original card. It works for everything, man. we're not talking about the communication themselves, Nigma. We're talking about validating that the hardware you're looking at is actually the thing you're looking at. And be aware understands. And we need to fucking we need to explain this. What's the point of all of this? If all of this, if I just fake if I just someone is using a fake PCIe device. Okay, communication is encrypted, a little bit like HTTPS. Okay, so whenever you communicate with, like, Google, your shit is encrypted. Same thing for PCIe. So this is already fixed. Now the second part of it is making sure the target is okay. This is done through signature. Like, is the target truly the person that it is? I look at the signature, I know. And by the by, a vulnerability would absolutely not say that the design is good or not. So if, let's say, NVIDIA makes a shitty card that doesn't do the check correctly, that's on them, right? It's not because the design of what Intel did, or what AMD did, or what any of the PCIe devs did is wrong. Okay, what is the point of all this? What is the point? What is the point of all of this if someone is using a fake PCIe device? Chapter 4 of this. Haha, we're getting in. Oh, is this a malware? Alright, where the fuck did you find this? You've got the full link. I'm a retard. Give me a second. Okay. Oh, whoops. I did the retarded thing. Okay, so you're telling me that I cannot, like, see the source of this shit? How am I supposed to do this? No, you didn't see jack shit. Okay, thank you. God damn, that was complicated. Alright. Bro, fuck you. Alright. Alright, so they kind of just outline, but like we already had a big idea with this. Alright, I'm going to not have enough time to fucking end this. Okay, the skeptics among you might say, what is the point of all of this if someone is using a fake PCIe device? But it explicitly explains the source of the certificates. Really? Does it? Brain didn't brain enough. What parts? Chapter 4 of this. 4. The device shall support device application, page 49. Okay, should I go to page 49? What the fuck? Page 12? Bro, I'm so far. Okay. The TVM will get the device certificate and measurement from the TSM. Then the TVM will verify the device based on the TVM specific policy. For example, the device certificate must have a trusted root certificate authority, and the device measurement must match the latest reference manifest published by the device vendor. Okay? This is exactly what was written at the other place. If the verification passes, the TVM can accept the TDI and use the TDI SP protocol to manage the TDI. If verification fails, the TVM will reject the device. He doesn't remember, he read them right the fuck now. Step 4, you're saying? Page 12, explanation, yeah, it's not chapter 4. 4 goes into detail. Okay. Well, it's pretty fucking like default, right? We're just exchanging keys, verifying against a certificate. Disallow to have a policy that's specific to repository and open hardware to anyone while keeping it safe. Yes. All right, we agree. All right. Is there like a fancy name for this? Fuck, I'm too far. Yes, secure device interface. The standard got you covered. Got you covered. Upon initiation of a connection to a TDI, the TDI will transfer over a signed version of their internal measurement firmware version and what else? I think, yeah, well, we're going to, because TEEIO security model, like, doesn't give us anything more. TDISP is something else. It's like the whole fucking standard. So I'll just, like, not name it. Upon initiation of a connection with a TDI, the TDI will transfer a signed version of their internal measurement, firmware version, and other hardware information. The signature can be verified against the vendor supplied public, how do we call this? Key is like a little bit dumb. Fuck. certificate, I guess. Certificate. Okay. The signature can be verified against the vendor supplied certificate, and the measurement can be tested to confirm that the hardware wasn't altered. I'll need to go. I need to finish this shit real quick. The skeptics among you amongst the skeptics among you might say, what's the point of all of this if someone is using a fake PCIe device? The standard got you covered. Upon initiation of a connection with a TDI, the TDI will transfer a signed version of their internal measurement, firmware version, and other hardware information. The signature can be verified against the vendor supplied certificate, and the measurement can be tested to confirm that the hardware wasn't altered. Uses. Where do you see that? Is using uses. Ah. What is the point of all of this if someone uses... I'll rewrite this all. If the host uses... Thank you. Okay, what's the point of all of this if the host uses a fake PCIe device? Standard got you covered. Upon initiation of a connection with a TDI, the TDI will transfer the side version of their internal measurement, firmware version, and other hardware information. The signature can be verified against the vendor supplied certificate, and the measurement can be tested to confirm the hardware wasn't altered. This ensures full confidentiality without relying on any while relying on only the makers of your hardware. All right. Confidentiality. This ensures full. Now back to the kernel. All right, that's fucking great. That's very freaking great. All right. All right, I need to go. I need to fucking go now. So we'll see each other tomorrow. This was fun. And yeah, tomorrow we're gonna be back at 7. So sorry, Nigma. Tonight, I think I'll sleep early because I fucking need it. And tomorrow I got a big day of work. But now I gotta go take my daughter. So bye. See you next time. Love you all, folks. Love you. Bye-bye. Bye-bye. 6 hours.